那个停机。哦，好，没关系，我会进，我等一下会再进一个。好，那我们现在就先开始哈。OK，Alan。
Okay. So I think I already start recording. So maybe we can start our today's meeting. I will try to share my PPT.
他没有分享啊。OK。
Okay, can you see my PPT? Get it? Wait, maybe this one.
OK。
Okay. Good afternoon, everyone. I hope everywhere you go, anywhere you stay, you always in a health condition. So please take care of your health in this pandemic situation. We don't want anything happen to us. Okay? So today's presentation, I will presenting the durability. But the first section, I think the durability have two sections to discuss. So this part is about the first section. Okay, for today's outline, we have six major discussion. I think the first one is definition of durability, and then the second one is about deterioration of concrete, and the third one is about permeability. Next, we will discuss about physical deterioration. The physical deterioration we will discuss more later, and so do with the chemical deterioration. The next one is as I promised before in the early meeting. Actually, I bring the special topic that's about non-destructive.
Alan stop， 停机。你叫他看，停机，你看一下镜头。太久没看到你了，嘿。要回应了，你都常常都已经太久没有听到你的声音了。那镜头不要关了，这样子我们听 Alan 哈。Alan OK，Thank you。
Okay, thank you, Professor. Okay, I will continue my presentation. First, we will talk about definition actually. Let's discuss about definition. For durability itself, actually, that's related so much about our synonyms with the long surface life. Actually, when we imagine it as a human or as a animal, we can imagine it as how they survive in their life, something like that. But durability is specific for structure. Is it? We don't know. Is it more a concrete structure or reinforced concrete structure? And then, based on SCI Committee 201, actually, the ability to resist weathering action. Okay, let me remark the weathering action. This one, weathering action, and then chemical action, and then abrasion, or other process of deterioration. Actually, weathering action is about seasonal weathering like hot or wet season, like rainy or sunny days, something like that. That also can make some impact to our concrete. And then chemical attack. Later we will discuss more about what kind of chemical attack that can impact our concrete. And then we have abrasion here. Actually, abrasion is about the frictions between two solid material. So this one is the friction from the concrete surface, and then maybe friction with the another solid surface, and the other one is other process deterioration like erosion maybe, but erosion is specifically uh, because of liquid or some solutions, something like that. Okay, Gary.
Yes.
Yeah, maybe can you try to translate this part?
那这边我大概就简单讲一下，他刚刚讲就是这边在讲那个 durability 耐久性的定义嘛，那就是长时间的的一个耐久性评估。那它下面就提到第二段，各位刚刚看到就是会评估的几个因子啦，那就是它里面会有画出来的，像是天候条件啊，然后化学的一些反应，然后磨损，还有其他可能会损坏我们混凝土的一些相关的一些这个就是我们有关耐久性的定义要去探讨的。Okay, continue. Thank you.
Okay, okay, thank you. And then in our case, as a engineer, as a professional engineer, the first thing I would like to ask to you all is why we should aware about durability. This is a basic question, but very important. Gary?
那就是作为一个工程师，那就是我们要先问自己说，为什么我们要去关心这些相关的因子 ？OK。
And anyone can turn on their speaker who have their opinion about this question.
这个那就任何人有想要回应的吗？就是回答，说是有什么任何想法都可以现在直接开麦克风讲。
Of course, how can you use a material and you don't care about the durability? Durability is everything you need to care about, the life cycle of your concrete, your production. But I think in the durability, we care the most about the compressive strength and maybe the sinkage or the cracking of the concrete. I think so.
Okay, nice. Gary, can you try to translate it, Hugh's opinion?
You mean me?
Can you try to translate Hugh's opinion?
Alan, your mic is really not clear.
Oh, okay.
In trouble.
Can you try to translate Hugh's opinion before?
就是刚刚那个 Hugh 讲的，就是说，刚刚他讲那个什么，那个，反正你要考量到它生命周期嘛 ，life cycle。那如果它的长久性无法保证的话，为什么就是那工程师当然就不可能选这种材料 ？OK。
Okay, thank you. The other students maybe.
其他学生
your opinion.
你们有任何想法
Before I continue.
Okay, for me, I think it's about the
I agree so much about
total price.
Oh, sorry.
Oh, sorry. Oh, I'm changed.
Oh, yeah. Okay, please.
Okay, I think it's for the durability. It's about the total price on, total cost on life cycle. So
total cost. Okay.
Total cost.
Yeah.
Yeah, on life cycle. So if the durability good for long term, the total price is cheap. Okay.
Total price.
Cheaper.
Okay. Is cheap. Sorry, I draw with the mouse. Quite difficult. Yeah. That get the point. Thank you so much, seniors. His opinion is also good. Actually, when we aware so much about durability before we create the concrete, uh, that will be saving so much money. Actually, when our structure become damaged before the time or got the early damage, that will be very difficult for us to maintain it. Any kind of structure, actually, I think so. And this is why we should aware about durability. Actually, we as the engineer should control all the factors that are responsible for the lack of durability. I think that's very important. Gary, please.
那就是刚刚提到，刚刚我们讲的没有，学长讲没有错，就是主要是生命周期这个钱的部分。如果它的耐久性好，那从长远来看，我当然是省钱的。OK，
Okay, thank you. Let's say like this. When we have so much weapon, let's say we have weapon, we have knowledge. As an engineer, our weapon is our knowledge, our basic knowledge, our in-depth knowledge, our research knowledge. So when we know more about durability, we can control our structure actually. So we get a lower cost, we have no maintenance, but that is impossible to have no maintenance at all. Actually, in a structure service life, they will have to be maintained in a regular time. If we can do that, we can maintain it 1 year, every 1 year. Once in 1 year is good. Okay, next, I will continue to the iteration of concrete. As we know that the major component of concrete structure is aggregate, and then paste, and then reinforcement. That's special for concrete structure, reinforcement concrete structure. But on the other hand, we have another factor that can deteriorate our concrete. That is chemical factor and then physical factor. Both factor actually associate with the water. So our main problem actually, if I can say, after I arrange this presentation, after I try to learn this presentation, I think the most important thing for concrete structure is water. That's very important. How we prevent water penetrate to our concrete. How we prevent the existing water inside the concrete not to evaporate. That's very, very important. Gary, please.
那么就组这个表了，就是最主要的当然就是跟砾料，然后还有上面表砾料，还有水泥浆，还有它里面的那个加强材有关系。那同时还会受到化性跟物性，那这两个它强调就是非常就是跟水有相关性。那右边是课本的表，他说呢就是一些可能会影响到的一些相关的因子。OK。
Okay, thank you. And then let's see the table. I take this table from Metha actually. Oh yeah, I think from Metha. Or sorry, I think take it from Young. Durability of concrete. Actually, we have two parts that will.
Alan, sorry.
Yeah.
Stop. 我问同学，就是问台湾的哈，因为他对英文他们没问题。我问同学，你看一下 Alan 的这个 table 8.1 啊 18.1。好，物理的侵蚀，因为在这个耐久性，物理的侵蚀和化学的侵蚀可以告诉我哪些吗？我只是要看同学你讲出来，你才会有知道耐久性到底要探讨的是什么。来，我要点几个同学我比较没听到声音的哈，来，我先化学侵蚀先点停级好了。 然后等下 Kevin 你就讲一下化学侵蚀，好来，因为这英文的他们没问题，然后来那个婷锦，你告诉我化学侵蚀。
Okay, thank you, Professor.
婷吉
may I
，Hello， 婷吉，来，
Oh, okay.
哪些东西是属于耐久性的一个化学侵蚀？其实化学侵蚀这很这个英文应该很 OK 啊。那你用打字的，你用打字的。因为常常没有声音的同学，我会一直问哦，我才知道你们上课有没有在听。碱骨材 yes alkaline aggregate reaction， 然后呢，硫酸盐侵蚀sulfate acid， 然后金属腐蚀，然后呢，酸碱侵蚀，还有呢，酸碱侵蚀。好，还没有，那你继续翻，把它写全部都写出来，至少让台湾的学生知道，你们要知道什么是化学侵蚀，什么是耐久侵蚀。那 Kevin 呢 ？Kevin，
也是要讲化学的吗？
你讲物理的。
哦，物理的话就是那个动容作用。
Yes， 然后再来呢？
然后第二个就是干湿交替。
对，没错哈。再来呢？
然后第三个是温度影响。
Yes， 再来第四个呢？
最后一个是磨损侵蚀。
非常好哈。那婷姐你只有写3个哦，还有呢？还有一个啊，我刚才有讲酸碱侵蚀，酸碱的一个侵蚀啊。所以同学要知道，我们在探讨耐久性，我们如果针对化学跟物理的话，这边把你整理出来这些性质，它而且在 chapter 第几章它都有讲。所以我希望同学，我会这样子，希望同学能上课稍微认真听一下。Alan 准备的很不错所以大家认真听一下。好 ，OK Alan，sorry。
Okay, thank you so much, Professor. Let me continue the presentation. Actually, this table will talk about two kinds of attacks. That is chemical attacks and physical attacks. Okay, in this discussion, I think I just take some of these chemical attack. I just discuss some of this chemical attack. I didn't take it all actually. The first one about the chemical attack is I will explain more about bleaching and efflorescence later. And then also we'll talk more about sulfate attack. And then we will also talking more about alkali aggregate reaction. And then for physical attacks, we didn't talk about freezing and thawing because I think Taiwan didn't experience this kind of problem. And then wetting and drying is a common problem in every country, I think, but not all of the country experience the drying. And then temperature change, but in physical attack, we will just discuss about wear and abrasion later. So when you see the patterns is here, like can you see my that point? Here is every every attack here, every damage can cause some surge to the concrete component. Actually, this is for indicate the most affected material of the concrete. P is for pace, this one that you can see. And then if you see this one, we got the A. A is for aggregate. And then R is for reinforcement. Usually reinforcement will be related to the corrosion of metal, something like that. Okay, I will continue. Okay, this is the structure of water. Maybe you guess, if you have another laptop or another gadget, you can open your Metha PDF, chapter 5, page 1 to 4. Here we will talk about what kind of structure that exists in water. Let's say okay, actually water have a very small molecule, okay, and then water exists from covalent bonds. Can you see this red arrow? This is the covalent bond that will be connected or connect between oxygen ion and hydrogen. But this is just for one molecule, one water molecule. Actually, this is still unstable. Let's say this part is here for this part. So to make it, this is in common water molecule. This will connect for the other water molecule to become stable. Actually, this kind of hydrogen will have another bond for another bond. This one and this one and this one. Actually, I take it from internet. Maybe I will show you later. This is called hydrogen bonds. So the bond between one molecule to the other molecule, that's called hydrogen bonds. You know, for more complicated structure in water, actually that exists in ice form. So in ice, actually we have more bone to more bone to describe. But here, you know, when ice water, no ice, but ice rock, okay, ice rock, actually ice will melt on 0 degrees Celsius. Actually, when approximately 15% of the hydrogen bond cracks, that will be melted. Okay, and then for the density for the ice have a density approximately about 0.917, and then after melting, that will be increased, become 1. Okay. Kitty?
OK， 那这边就是在讲水的分子结构啦，就是水在里面的影响。那从先说，就是水是以分子形态，就是他们都知道存在混凝土里面。那所以他刚说中间这个图可以看到，就是一个氧2个氢嘛。然后这些水分子是以共价键的形式组成。那当然这是化学能非常的强，所以我们平常探讨的是右边这个，就是水分子的氢的 H 啊，跟其他的水分子之间的连接。那这个叫做hydrogen bond 那个氢键。那刚刚提到几个数字啦，就是说 大家都知道水是固体的时候，其实这个的氢键非常多，因为它就是被压缩，然后彼此之间联系非常高。那当应该说冰块融化的时候，那0度的时候，它的氢键大概有60%的话会化掉。那它的那个压力不好意思，不是压力，那个密度 density 密度会从0.917左右会变回水的1。对，那就是我们就是里面的那个力膨胀力主要是来自这些水分子之间的作用力，那这是它的化学的原理。OK。
Thank you. So let me try to more simplify my explanation. From these two kind of structure, the left one, I mean the structure of ice, this is the first structure, and then this is the second structure. Let's say this one is for normal water, and this one is for ice water. Which one is more have a higher impact to our structure? Let's say we have a concrete structure, okay, and then we have two kind of water. We have water and we have ice water. Which one is more damaging to our structure? Can you get my point?
You mean ice water? You mean ice, right?
Yeah, just ice.
Not
water. Yeah, sorry. Just use ice.
Can you be more specific? What kind of damage to our structure? Yeah.
Actually, let's say make our no force, okay? No force. Like just make it soap, something like soap. So some water may be penetrate to our concrete structure. Which one is more causing damage? The ice one or just the water one?
他现在这边提出一个问题啊，就是说，以我们一般的混凝土结构来讲，是冰，就冰这个结构的水对混凝土造成的破坏比较大，还是中间那个游离形态的水造成的破坏比较大？就各位看有什么想法？
Something like that. If you get my point, that will be on Metha page 1 to 5, 125. That will be there's some key point there that describe not for damage actually, but the water, just water, okay. Water at the room temperature, it has approximately 50% of hydrogen bond broken. Okay, actually, when we have more hydrogen broken, that will be more liquid. So I think that will be more easy to penetrate inside the concrete, and that will cause more problem. For the next season, for the next slide, we will talk about why penetrating water or why permeability of water is very dangerous to our concrete, in our hardening concrete. Okay. Let's continue. This is a common permeability equation, I think. Most of equation is can derive from this. Actually, this one is for
answer in the chat room.
Yeah.
There are some answers in the chat room.
Oh, actually, I cannot see the answer because I'm doing the presentation. But wait, I will check.
Okay, anyhow, so I'll read it for you. So Ifan said the water and ice will give different damage. Like the ice will give the freeze and thaw. And from Tinji, the junior, he said he thinks the water will cause much more factor because the ice is only in the freeze and thaw, but the water will have a lot of different kind of damage.
Okay, wait. I will. Which one did you just say before? I just checked the chatting text. The water and the ice will give different damage. I think the ice will give freeze and thaw, altitude and thaw. Yeah, but we didn't discuss about the freeze and thaw. But yeah, that's kind of a good answer. Sorry, Gary, can you read me for the last text?
So he thinks that the water will cause I'll put it this way: the water is a reason for much more damage to the country because the ice only cause the freeze and thaw problem.
Oh, okay. Yeah, that's a good answer. And the last one?
They are the same.
The same. Okay. Yeah. Good. Thank you so much, guys. Actually, when I do the presentation, I don't know how to check the text. So yeah, I will back to presentation. Okay. So if you guys have some answer, just say it with your microphone is better, I think. Okay. Yeah, back to here. Permeability is defined as a property that governs the rate of flow of a fluid into the porous solid. Okay, this one. Yeah. Let's say in concrete also will experience the permeability, but you know, in soils also, any structure that have porous solid will experience permeability. I think that's a key point. Okay, and then this is the common equation that we have here.
那就是我们要来看的，就要看一个它的所谓是密水性的部分，或是说它的渗透率 permeability。那这边它就是有个公式，应该说这是来衡量水渗入外界的水渗入我们混凝土孔隙的一个程度的一个速率。那公式就如下面。continue.
Thank you. Okay, this one is for rate of the flow, and then this K is for coefficient of permeability. That's actually depend on what kind of material that will have at the time. And then we have a viscosity fluid, and then we have a pressure gradient, we have a surface area, and we have a thickness of the solid. Okay, now, okay, let's see this kind of table. If you can open your Metha, you will find this table. Actually, in the fresh mix cement phase, they will experience the hydration progress, right? Now, in the hydration process, actually, if we see this table, we are talking about the coefficient of permeability. For the fresh concrete, in a age of 5 days, 5 days concrete. Okay, actually, the coefficient of permeability is higher. What happened? Why? Let me. Oh wait. Okay. Yeah. In this 5 days, we have higher permeability coefficient. What happened? While in the meantime, when our concrete become more hardened and then become fully achieve the strength, that will be almost very small coefficient of permeability. What happened? Eric?
那这边就是说，从这表嘛，那他提出个问题，就是说，为什么我到5天，或是说我们说是完全刚新办混凝土的时候，它的是那个这个什么透水性非常的高，那随着时间发展后，它的透水性就急速的下降。那有没有人可以给出一些可能的理由是什么？可能的原因是什么？Anyone？
Anyone? You? 一般
来，我点名，这个应该不难回答哈。来，
不好意思，我刚已经按了。
哦，好好，非常好，学长讲。
不好意思那个是因为等一下我先问一下，那个次方是 power 对不对？
像你说哪一个？
就是 -11那一个，是不是我们应该英文讲 power 嘛？
哦，对。
好 ，OK， 好，我先用中文讲好了啦，因为这一个水灰比是0.7啊，所以其实它相对是比较低的。那它在它不同的年纪的时候，它的渗透率会逐渐降低，是因为它的那个结构水化程度造成的。当它越水化越完整的时候，它会造成它的那个等于是结构被阻塞掉了，所以到最后差不多6乘10的-11次方，我的经验是觉得这个是就是大概就是这个样子，因为我们一般的混凝土大概会如果高的话会到-12、-13嘛，的样子啊，所以基本上主要还是那个水化程度造成的阻塞，让它水路不通了，大概是这个，我觉得是这个样子。我在用英文讲，还是请翻译好的啦。
像都可以。
好，那你翻译好，不好意思。
Okay, yeah. So as a senior said, so it's mainly about the hydration. So as the hydration process continue, like all the pores and all those like void inside the concrete will be blocked by the hydration products. And the senior also mentioned, you can see that from this table, they use a sample with the water cement ratio of 0.7. So the ultimate coefficient of permeability is around 6 times 10 and the power of -11. But usually in his experience, that if you use the ordinary Portland concrete or even the high strength concrete, the degree should be 10 and power -12 to -13. It should be that low. So yeah.
Yeah, because in the table 5.1 that's specifically for 0.7 water cement ratio. Yeah, I agree with that. I didn't discuss the other type of water cement ratio. Yeah, thank you so much for that. And the answer is correctly, or let's say this. I think I agree with our seniors' opinions. When our concrete become more hardened along with the time increase, the capacity inside of the concrete will be decreased, and automatically the permeability will be smaller. Okay, but theoretically, let's say in a meta say that theoretically, with most well-cured concrete mixture, actually, cement paste should not be the principal contributing factor to the coefficient of permeability of the concrete. Right now, we are talking about the cement paste, okay? Later, we will talking about the aggregate. In Meta, he said that this is not the major, not being the principal contributing factor, actually. Okay, next. Let's see for the permeability of aggregate. Before, we already talking about cement base, and now we're talking about aggregate. Let's see this kind of table, okay, table 5.2. in Metha, different type of rocks actually have different permeability coefficients. And let's see, this is the water cement ratio that have same coefficient permeability. Now, this is the range of coefficient permeability that have equal water cement ratio. Maybe our seniors already see this kind of table. So yeah, different type of rock will have a different permeability. Now, in Metha also, it said that volume of pore under 3%, okay, volume of pore under 3%, rarely more than 10%. And then this kind of volume pore is for aggregate, but there's some exceptional. For some aggregate with more than 10% porosity show higher permeability than cement paste. Even cement paste have a 30 up to 40% porosity. That will happen actually because capillary pore of the aggregate usually much larger. Okay. Okay.
这边要配合刚刚，sorry，那这边要配合刚刚上页来讲，就是刚前页是在说，跟刚各位应该有看到右下角那一段，就是基本上理论上来说，从头来哦，上页在讲水密程度，沥青什么配什么讲，沥青浆体对的那个水密性程度。那基本上只要你养好是不会有太大的问题的。那这页是在讲它的那个力料造成的影响。那首先先看左边这个，它就是使用不同的石头，竟然它的差距会非常从0.38影响的那个了，从0.38到0.71，就是这个的影响非常大。所以各位要注意到这个力料的部分。那但是右边这边它有提到蛮重要，就是假设我同样使用10% 孔气率的力料，应该说半环或是10% 孔气率的混凝土，那跟其他的它的水泥浆体在30到40%孔气率的这个比起来，我的力料造成的水密透水性反而比水泥浆体还大。那他说导致的原因可能就是因为刚刚说，因为它虽然只有10%，但是它本身的各个洞都非常的大。那所以在力料这边是要非常注意，它造成的影响最多。那它同时它的不确定性也是最大的。OK.
Okay. Thank you so much. Anyway, guys, if you have any question, just please turn on your microphone and then say, "Aaron, please stop," and then I will stop. We'll hear your question. Okay. Next. We're talking about the permeability of concrete. Okay, before we already talk about
Alan.
Okay.
Sorry, I want to ask classmate questions.
Okay.
来，我问同学哦，刚才 Alan 在讲哦，因为影响到耐久性那个致密程度是就渗透性是非常非常重要的。你们先告诉我我点同学哦，就是没在镜头的我会先点啦之后再轮流那个可能玉央或者是上风没在镜头的我会先点。刚才影响到我们整个混凝土里面的渗透性在这边刚才 Alan 有介绍，会有哪几种？玉央好了，玉央我看到镜头了，玉央。那个新郑凯，你可以跟他们讲说我在问什么就是影响到 整个混凝土的一个渗透性好的材料大概有哪几个？
主要是，
喂，你说。
影响混凝土致命性的主要是会来自那个胶结材料，再来就是它的水化程度。
好，主要的，因为刚才 Alan 在介绍，你看他在渗透性就是 permeability 这个部分，他会介绍几种，就是一个水泥的一个部分哦，还有一个是什么？还有一个是骨材。然后针对这个几个的渗透行为，他来讲之后，他在介绍整个混凝土。那当然水泥的浆体部分，水泥浆体部分的渗透性跟它水化的程度也有关，跟它水，然后刚才学长讲的，它水位比越高的时候，孔隙结构一定是比较大的。那随着水化程度的时候，它的孔隙结构当然就会比较不一样，渗透系数会下降。那骨材本身就是它自己本身的特性有的骨材比如讲说火成岩、沉积岩、变质岩，不同的骨材就会有不同的一个渗透的一个行为。那刚才 Alan 在介绍这个的时候，就是这些部分都将会影响到我们的我们的整个混凝土的一个部分。那混凝土在讲渗透性的部分，我大概讲一下这个可能课本不一定有讲到，有一些是有连通的这渗透行为跟有连通跟没连通的孔隙结构其实是有关系的，有些人就做这些相关的一个研究这渗透一个行为那我想这边我等一下因为之前其实有做一些讲义啦那但是都是中文的，我稍微贴一下给同学你们自己看一下那因为 Alan 这边他讲英文的话我就不再那个那 OK
So the professor add some details. So Alan, you say correct that the first one will be the cement paste, which affect the permeability and of course the aggregate. So if we look more detail, so in the end, it's all about the pores, the porosity that inside the concrete, right? So there are so many research. They are researching about the deformation of the pores. What do you mean by that? It's like the pores should be connected to each other, so the permeability will be bigger. But in some case, you might have the same porosity, but which their pores didn't connect to each other, which will lead you to lower permeability. So there's a lot of research which focus on how those pores, which they are connected or not.
Okay, thank you so much. It's a good explanation actually. Wait, I will take a minute. Okay, yeah. Can we continue? I'll take maybe 2 up to 3 minutes again. Okay, let's talk about the permeability of concrete. Now, let's see this graph, and then let's see the explanation. Okay, the addition of aggregate, like Professor says, to the cement base of mortar actually can increase the permeability, and then larger aggregate size that will be greater coefficient of permeability. This is another question actually. Why the permeability of mortar or concrete is higher than the cement base? This is I think this one is another extended question, but maybe okay, wait. Get it. Can you translate this part? So before take a break, the other can try to answer this part.
那就是我们这边来探讨，就是刚刚他提出一个问题啊，就是为什么透水性来说是砂浆会比我们的水泥浆来得高？对吧？那就是这一章要探讨，各位有什么想法？
来，我们就轮流啦哈。那个上峰你没有讲，就是为什么混凝土 我们用混凝土来讲比较那个，混凝土的渗透性会比水泥砂浆水泥浆体的渗透性还高。Why?
Okay. That will be our next discussion after the break. But, can we take a break for 10 minutes maybe?
我先讲。
Wait, the professor asked a question for June.
Oh, okay, yeah.
好，那是因为它本身的孔隙率较高的关系，所以才会有较大的渗透系数。对，
好了，那郑凯，你有没有什么想法？
是不是跟 ITZ 有关系啊？
都有。有没有同学要讲一下？学长呢？学长一直被我问，还有没有谁？明玉，你有没有什么看法？
我觉得我可以讲哦。
好。
我觉得这一个跟那个第9页的那个可能要同时考虑。其实这个地方应该是纯粹是这种的关系，但是如果大家要研究这个议题的时候有一个地方可能以后可以去考虑的，就是说照理讲，如果照这样讲的话，那加了骨材以后，再加上第9页那个考虑，可能不止沉积这种的问题会造成它的渗透性更高。可是有时候当那个孔隙材料像我们讲滤材一样，滤材会被堵塞。那个我们不是那个陈老师他们研究说，那个透水性骨材的过了一阵子以后就会被塞满了嘛。其实我以前在做渗透性的时候，也感觉有这种现象，就是在某些情况下可能就是水头的里面的那个材料被溶出以后，被挤到那个水尾的，就是那个我们 sample 的尾端的时候它会变成累积在那个地方，反而变成那个长期的话会变成那个孔隙率降得很低我是没有去探讨那个原因的，但是以前我有把它试题我做砂浆去把它切开来看过，会觉得说那整个那个水尾的部分亮度比较高，感觉就是变成比较致密。可是如果是刚开始的时候，其实把它切开来是蛮均质的所以我不知道这个可不可以解释说我们在做实验的时候，开始的时候可能蛮稳定的，可是到最后有时候会发现有些数据会变成跳。可能那时候就是说有的被堵塞，有的没有被堵塞。可是这个如果没有长期或者比较高的数量去做试验的话，有时候没有办法去侦测出来。那这个只是说我解释，如果我们做不只考虑纯净性重的时候，也考虑说那个骨材本身的渗透性的时候，可能会有造成这种混凝土会比砂浆渗透率更高的原因。完毕。
很好因为我大概稍微提一下有一些东西啦，就是说刚才郑凯讲的，还有学长讲的 ITZ 的问题，确实因为比如讲说我们水泥浆体就是一直在不断的水化水化生成水化产物，孔隙或者水化的程度让它孔隙更致密。可是加入了骨材就不一样了，它的界面就开始出现了。那界面如果有裂缝的话它渗透性相对，而且 骨材越大的话，它的渗透性会越大。好，除了这个界面过渡区的一个裂缝的一个问题之外，还有一个可能课本也不一定有讲到的，叫做那个什么连通孔隙。我刚才说有一些孔隙它比较因为有骨材加入之后，它的孔隙结构比较容易，就是等于说孔隙一定会有孔隙的产生嘛，孔隙跟孔隙之间就会有一个连通性，有一些地方就会有一些的连通性，这也是造成渗透性的一个部分。那当然就是在界面过渡区影响会更大啦，这个部分其实是很重要的，所以界面过渡区的一个部分生成还有它的裂缝的一个问题是最主要的一个原因。那当然在课本里面没讲到刚才说的这个孔隙的连通性也是一个很重要的一个探讨的因素啦。好，没有，只是大家一起思考，我觉得 Alan 不错啦，他会提出一些问题让大家去思考，我觉得很好。那只是说时间的关系，我们再看看怎么样。如果都不够的话，我们礼拜3的部分就小组讨论的部分，我们再拿过来再讲，继续讲一下。因为我觉得耐久性是硬固混凝土很重要讨论的一个因素。我觉得大家这样互相讨论，即使我们就算没考试，我觉得也不错，就大家这样互相学习啦。好。
So the professor mentioned as you say about porosity, which is a big concern in the permeability of the concrete, and also the pores inside porosity, if they are connected or not. And as the senior mentioned about the ITZ zone, the interfacial transition zone, that's also a big issue here because the crack. Because the crack which happens between ITZ zone is a really big issues. Okay, and in the end, the professor say like if you don't have enough time today, it's okay, just continue. We can find another time for you to finish.
Okay. So maybe we should just continue. Is it okay, guys? Actually, I still have 1 hour, so I'll try to as long as I can, as far as I can to discuss this PPT. Is it okay? So
各位他已经开始了，要休息一下。
大家要休息吗？没关系。假如说今天如果真的时间花很长，没关系，我们就下礼拜3。我们下礼拜3不是有2节课吗？我就不小组讨论，因为现在非常时期，我觉得在讨论耐久性还不错，因为耐久性是我们硬固混凝土很重要的一环。大家这边多一点点聊天多一点学习还不错啦。好，那就大家先休息，OK 吗？看 Alan，
So Alan, depending on you, do you want to take a break or not?
Yeah, sorry.
So Alan, depending on you, like, do you want to take a break or you want to continue?
Actually, I get the feel, so maybe can we continue, guys?
那他说因为时间关系，就继续下去。
I will just continue. Okay.
那就继续下去。
好。
Okay.
Yeah,
okay. I will continue. When we talking about the permeability of concrete, actually that has some significance to the physical and chemical of concrete deterioration. So the physical and chemical cannot stand by their own. Even they have their own impact, but actually they make it worse when the impractical issue they will making worse one each other impact actually. Now let's talk about how to control the permeability of concrete. This is a very important issue as when you are working as a professional engineer or working in this construction work. You should know how to control the permeability of concrete. Now, strength and permeability, they all related to the capillary porosity. Okay. First, the pesometrics. When capillary voids is decreased, okay, the permeability will be decreased. So when we have no space inside in the concrete, or small space become little space inside the concrete, the permeability what happened? Maybe that will be happen, but permeability will be decreased so much. Okay, how to do that? Okay, to do that, we can create our concrete, or we can make our concrete to have a low water cement ratio. Okay, and then the second one is we should have the adequate cement content. So the cement content should be proper. Okay, and then the third one is proper compacting and curing. So our technique to do, or to create our concrete will be have significant impact to the controlling the permeability. Okay, Gary?
那这边就让就开始后面要讨论，就是要怎么去就是既然这个 permeability 这个致密性这么水密性这么重要，要怎么去改善？那第一个点就刚刚前面提到嘛，就是有关于孔隙率的部分。那他这边提出三个改善项目。那第一个大家可以看一下，就是当然就是降低水灰比。那第二个就是你要有足够的水泥含量去形成足够的水泥砂浆。那第三点就是充分的导石还有养制。反正最终来说就是这三个会影响，会导致我的孔隙率降低。那孔隙降低，当然最终就会有比较好的水密性。对 ，OK。
Thank you so much. And then the second one, we have micro cracking in ITS, right? Even we haven't do our another exam. There's the first step in micro cracking in ITS. I think all of you already read about that. So we should decrease the micro cracking in ITS. How to do that? Now, to do that is we should have aggregate size and grading. We should make a really big concern, or we have to pay more attention to that one. And then the second one is we should make another proper attention to thermal and drying sinkage. And then another one is we should pay attention to the perimeter or excessive loading. So before our structure apply to the loading, so be careful our concrete structure not to apply any load. Okay.
那这边就讲要怎么去增加改善我的 ITZ 嘛。那他特别提到说，第一点要特别注意，基本上是影响最大的，就是你的力道的尺寸，还有你要去决定它的，主要它的级配。那当然就是减少，那就另外来说就是减少它的因为温度还有干燥产生的干缩现象。那对啊，然后就是不要过早的过多的载重了，那基本上就是会产生微裂缝，导致裂化。那下面就是改善的方案。那他说第一个重点是要特别注意。OK。
Thank you so much. Now we will continue our presentation. Like for physical attack, we will discuss about surface wear. I think before we do the online exam, midterm exam, Kevin already discussed about this kind of wear, this kind of surface wear. Okay, we have abrasion, we have erosion, and we have cavitation. And then for physical deterioration also, we have a crack. Actually, crack is some kind of effect. Okay, effect. Crack happen because volume change. The volume can change in a we don't know that in normal temperature or humidity gradient, crystallization of pressure of salt in pore, something like that. And then crack will happen also because of structural loading. Okay, when we have a structure and then we have a overload applied to our structure, that will create some crack also, and some impact. Okay, if we have, when we feel the earthquake impact, the structure will have some vibration, right? And then like cyclic loading also even happen in the earthquake. that depend on the how the earthquake happened. Okay, and then exposure to extreme temperature, freestyle, like I said before, we didn't discuss discuss with this freestyle, or fire, but fire may be, but for fire, actually fire is common happen when we didn't know, like electrical problem that will cause some fire. We didn't know what happened to our structure, right? But I think some research already doing the in-depth research about impact of temperature or increasing the temperature, like exposed to the fire. Okay, I think also American standard has uh, this kind of what we call that. Sorry. Evaluation for the existing concrete structure that already applied or already kill the fire. Now, next, this one is for physical wear, like I said before, we have abrasion, eruption, and gravitation. Abrasion is generally referred to the dry attrition or some kind of friction, okay, such as case of wear on pavement, and then industrial floor or by vehicular traffic. That's kind of surface wear for abrasion. And then erosion is specifically for the liquid or fluid containing solid particle in suspension. Like erosion, we have like the canal lining, and then the spill of the dams, and then concrete pipe for water or sewage transport. For the cadivation is loss of mass by formation of vapor bubbles, okay, and their subsequent collapse due to the sudden change of different rapidly flowing water. Now, like in my PPT, abrasion resistance concrete surface, we have ACI committee 201 that report the standard testing, okay, or the standard code for abrasion resistant concrete structure. And then to achieve good resistance in abrasion, we should have concrete strength more or equal 28 megapascal. How? This one is the detail that I got from Metha. But actually, if you go through the code, I think the code some code will be already describe how to achieve 28 megapascal or maybe close to 28. Okay, this should be low water cement ratio. That's the first one, and then the second one is a proper grading of fine and coarse aggregate. So that we have a maximum dimension of aggregate that will be at 25 millimeters, and then lowest consistency. This is related to the workability, I think, for the maximum slum test. I think you have experience testing the slum. That should be maxima for 20, also for 75 millimeters, and then minimum air content consisting with exposure condition. Now, let's say I will keep going through. Okay, if you have any question, just please stop me. Okay. So for the physical deterioration, also the rate of surface erosion. Okay, we are talking about the erosion. That kind of have two major parameter. Okay, the first one is that will be related to the porosity, and then that will be related to the strength of concrete. Okay, and the second one is moving particle. Wait, this one. Yeah. Oh, sorry. This one. moving particles, this one, okay, the amount, the size, shape, density, hardness, and velocity. If all of that parameter, all of that category is small, this one is for small, the rate of erosion should be, or we can say that we can negligible the rate of erosion. But in case okay, in case this all parameter is have a big dimension or something like have a higher in every aspect, so we should pay attention to this kind of specification or this kind of recommendation. Okay, if you reading through the Metha, this all in Metha. The first one is we can use the hard aggregate. Okay, and the second one is obtain 41 megapascal at 28 days for the before exposure to aggressive environment. So, sorry, let me delete this one. Okay, and then the last one is at last for the 7 days of we should do the continuous moist curing that is recommended by the ACI Committee 201. Is it okay? Or Gary, maybe? Can you make a short explanation for this?
那这一页其实就在讲，就是当我们我这样全部都在探讨那个耐久性嘛，那就是关于或者密水性的关系。那这一页是在讲那个表面的磨损。那它其实开宗明义，这个Masa 也直接讲，就是这基本上是可以忽略的啦。那各位就是它对耐久性的影响非常小，可以忽略。但如果真的以后真的有遇到的话，那就是参考它里面标出来的这几项，就是像用比较硬的粒料啊，然后还有参考那个 ACI 委员会201号文件，就是相关的措施。那这个基本上影响非常小。OK。
Thank you. Okay, next. This one is we still talking about the physical deterioration. Okay, and if you see this kind of picture, actually in my previous version, I didn't put this picture. Now, let's see this graph, and then let's see this kind of lines, this kind of rock. Okay. This graph is talking about the influence of water-cement ratio and aggregate type on abrasion, erosion, damage in concrete. Actually, different rock and different water-cement ratio will have different impact on abrasion, erosion, deterioration. Okay, this one is, let's say, wait. I will make some, yeah. Let's say this one is talking about water-cement ratio. Okay, water-cement ratio to the test time. This is the time, respect to time. Okay, and this one is respect to the loss of damage because of erosion or abrasion. Now, different water-cement ratio, water-cement ratio will have different degree of erosion. I think we can call that degree of erosion. For the small water-cement ratio in a same time, okay, that will have a lower abrasion erosion loss. This table talking about the percentage loss by mass actually. Okay, if we have a higher water-cement ratio respect to time, we will have higher abrasion erosion in the same time. Okay, now let's see, different rocks have a different abrasion erosion also. So which one is better? I think the better one is the lower water cement ratio with this kind of rocks. This will be have a good resistance to the abrasion or erosion, like this. Okay, this is a chat rock like this one. This kind of rocks, but maybe not all the region or not all the country have this kind of rock. Okay, so different kind of rock will have different abrasion erosion loss. Okay, and this one is a case from Metha, I think, for the cultivation damage. You can see it in Metha. This is the tunnel of the Grand Canyon there. Gary, can you help me to explain this part?
OK， 那这边就是课本里面有关于刚刚我们前面提到的水灰比啊，还有不同种类的石头对刚刚说这个磨损率的影响。那各位刚刚应该说的还很明确啦，就是我的水灰比越低，那当然我的磨损率就是比较少一点。那可以注意到左边的话，它的磨损率是用那个重量的损失去看的。那右边的话，它刚刚特别强调就是基本上就是不同石头，就跟前面提到跟硬度有关系。那最下面那个 CHERT 我查一下碎石，看起来应该是火成岩的一种，那就是石头越硬，它的损失率就越低了。那这中间是一些图嘛，最右边是说他说课本中有关于这个所谓侵蚀的一个实际的现象，那这是一个隧道，那隧道经过侵蚀后可以看到就是各种磨损的情况。So Alan, so about this abrasion and erosion, so does it mean that the effect under the weight?
The concrete, yeah, the concrete structure.
So the concrete was put under the
some kind of test, I think. That depend on the standard test.
Okay.
Okay. Ready? Sorry, Gary?
Yes, okay.
Okay, thank you. Now I will continue the presentation. Next, this kind of physical deterioration also happen in concrete. We call it latent deterioration. Okay, the process of physical attraction. This attraction is actually friction, some kind of friction. On concrete occur at surface. Okay, ensure the concrete surface has a high quality. To reduce the latency, this kind of damage. Actually, we call it not damage but defects maybe. To reduce the latency, delay the floating and throwing operation until the concrete has lost its bleeding water. So we should wait for the concrete to have bleed water first. Okay, and then doing the floating and rolling. Next, if we say this picture, we have concrete pavement, right? Concrete pavement, and another defects like this concrete also happen on heavy duty industrial floor. So these latents may be have or occur happen in this concrete pavement or heavy duty industrial floor. So how to design it so we can prevent this kind of defects? Let's say this one I got from Metha actually. We should have 25 up to 70 millimeter thick topping. So the cover is, I think this kind of cover should be at least related to this one. Okay. And then when we create our concrete, that should be have a low water cement ratio. And then we should have a hard aggregate. And the maxima for the aggregate, I think from the Metha, I'd say 12.5 millimeter. And then we can use a superposition admixture, okay, to have this all structure to resist this kind of defect. We should have a high strength of concrete, okay, and then we should have impermeability of structure, and then less prone to the bleeding. Or another way we can try to prevent this with another way. We have a surface hardening solution. How to do that? We can use magnesium or zinc fluorosilicate or sodium silicate that will have a reaction to the calcium of hydroxide, and then we can try to seal the capillary pore. Okay. Gary? Okay. Maybe I will just continue. Now, for the physical testing method, actually, let's say for the resistance of concrete, okay, for the wear resistance of concrete, this we have this kind of ESTM, okay. We have this kind of ESTM. We have two kind of ESTM, but these two kind of ESTM is not always satisfactory, like this, not always satisfactory, because the simulation of the field condition of wear is not easy to do. Okay, so sometimes the ESTM is for the qualitative evaluation. So the STM is not for the quantitative measurement. Okay. Now, can you see my PT? This one is the ESTM C779. Okay, I will briefly explain to you guys about this ESTM. Actually, this ESTM this is for abrasion resistance. Okay, but for the horizontal concrete surface, so like this one maybe, we have a concrete structure, and this is for the resistance of this part. This part. This is a horizontal part. Okay. Now, for the testing method, we have three procedure. Like we have procedure A, procedure B, and procedure C. So actually, every procedure you can choose one, I think, because we cannot say like we should use three of them. No, but you can choose the most proper one that you want to do. Just depend on you. That's why when we use ESTM, we should try the other standard also. We cannot use just one ESTM, because one ESTM will be related to the other ESTM standard. I think that's why I make this kind of box and then make it through here. So when we use this kind of standard, we should aware also for this kind of standard. Okay, when we use C779, we should aware also for the C418 or C945. Okay, and then next, this is the every procedure that I mentioned before for the procedure A, procedure B, and procedure C. But we won't talk more detail about this. Just in case you guys want to apply this kind of testing, I hope you guys already have some brief from this presentation. Okay. And then this one is for another abrasion test that using ASTM C418-5. Okay. Like I said before, every ASTM will be related to the other ASTM standard. So be careful when you use one ASTM. You should also concern about the other ASTM. Okay. Now maybe we can take a break, but this kind of session is I will have maybe from 3 or 5 minutes for discussion to end our physical deterioration section. After this part, we will talking about the chemical deterioration process in concrete. Okay, is there any question?
那这是第一 part 有关于物理性的耐久性。那各位有什么问题，现在可以大家讨论一下。下一节是要进入化学部分。
Okay, this is the end of the physical part, and then after this one, we can continue to the chemical part. Oh, so much text here, but I cannot see it. Okay, no problem. Any question, guys?
我先讲一下哈，耐久性在我们混凝土里面当然有物理性、化学性等相关的问题。那物理性的这个部分哈，可能就是在某些地方才会用到，譬如讲说，海水的一个侵蚀，或者是说路面等等的。但是我们更在乎的就是等一下他要讲的化学性的一个部分。耐久性的部分，我们物理的耐久性的影响跟化学的影响，你会发现说大家在讨论的时候，针对化学性的部分我们会探讨的更多，因为它影响的东西会比较大。那所以接下来下一个阶段是我们可能要花比较长的一段时间。那前面的物理性，我想我们就先不要再讨论，因为我怕时间不够，好不好？我们就是只是针对化学性，因为化学性的耐久性的问题是我们特别想要知道的，而且特别需要去了解的。
Okay, so the professor said the durability, the chemical behavior is what usually people is the most concerned about. And as for the physical one, in some situation people do discuss about that one, but still we focus more in the chemical. So let's just continue, okay? Alan.
Sorry, Gabe, can you replay? I think
Okay,
I lost my connection.
Okay, so professor said that so we know that the durability have either way in the physical and chemical, right? And physical, yes, okay. So and for physical is in some case we do discuss about the physical, but people actually more concerned about the chemical behavior. So please continue. Let's just go to the beta please.
Okay, thank you. Now let's talk about the chemical part. Okay. Wait, to share screen. Okay. Let's talk about the chemical deterioration. In concrete deterioration process, actually, that's triggered by chemical reaction, right? Involved generally, okay, but not necessarily. Chemical interaction between aggressive agent in the environment and the constituent of the cement base. But I got this from Metha. Theoretically, okay, this one. Theoretically, the environment with less than 12.5 pH may be branded as aggressive. Because why? Because it can reduce the alkalinity of the porous fluid, and then that can be also lead to the is a relation of the cementitious product of hydration. Okay, this means that most industrial and natural water will be aggressive to the Portland cement concrete. Okay, now this one also I got from Metha. For type 1, if we have a case like saltwater attack on calcium hydroxide and CSH present in hydrate Portland cement, okay, in the hardened cement base, that will have hydrolysis, okay, and the other thing that will happen is leaching.
Excuse me, and can you please put it into full screen, please, because I cannot see the words.
Oh, sorry. I haven't. Yeah, thank you so much. Sorry, guys. I didn't know I already put it in the full screen. Okay, let me continue. This kind of have a hydrolysis, okay, and then this is have a leaching. Both of this process will increasing the porosity. Sorry, I will make some pen. Yeah, this one. Increasing the porosity. And then this will lead or causing the loss of alkalinity. This one is the first one. Okay, and then the second one is the loss of mass. Every increasing the porosity and increasing the permeability, that will also lead to the increasing to the deterioration of deterioration process actually, or damaging process. And then the other one is loss of the strength and rigidity. Okay. Kiri, can you try to translate this part?
哦呀，sorry， OK。那那就是，但这边其实就跟他刚刚讲的，就是这样对嘛？那主要就是因为我们讲到化性嘛，那我们最主要是考量到里面的那个碱固材的碱性的性质。那其实我觉得这边不好意思，我觉得没什么好讲的，就是如图上所示了。对，那各位有任何疑问就再问一下。OK。
Okay, thank you. And then this one is for type 2, when the exchange of reaction between the aggressive fluid and the component of hardened cement base. Look here for the cement base, removal of the Ca and the removal of the CH of soluble products. Okay, and then this one is for insoluble products. These two of removal will increase the porosity. Okay, that will also lead to the same cause like the first slide. This is alkalinity, and then loss of the mass, and then increase the deterioration process, and also loss of the strength and rigidity. But for the substitution of the replacing CAs in CA and in CSH, okay, that will directly lead to this kind of problem, loss of the strength and rigidity. Okay, and then this one is for type 3, sulfate attack from essonite and gypsum, alkali aggregate attack, okay, and corrosion of steel in concrete, like hydration of the crystalline CO and CaO. Okay, this one is a formation of expansive product actually. This formation of expansive product is increase the internal stress. Okay, when our concrete already have internal stress, actually that's kind of detrimental effect already happened in our concrete, which will be lead to the causing of deformation. This is the first one is for deformation, and then the other one that maybe can lead to the crack, spalling or pop outs. And the third one is that can be lead or causing to the loss of strength and rigidity. Okay. Now, for the chemical attack, like I said in the first time, actually chemical attack didn't stand alone. Actually, chemical attack is manifest as a physical event. It's because when physical effect show up, that will be like increase in porosity, decrease in strength, crack and spalling. That will lead to the chemical attack. Why? Because our concrete already have some damage. Okay. In fact, several chemical and physical process of deterioration act at the same time and may even reinforce each other. Like I say, this is like a double damage impact. Okay, chemical and the physical, they work together, make it worse for our concrete deterioration. Please pay attention to the sulfate attack, and then alkali aggregate attack, and the corrosion of the embedded steel, as all of the phenomena are responsible for the deterioration of most concrete structure. Okay, now maybe this kind of explanation, I will bring it back to our case in midterm. So I would like to discuss more about what kind of answer that you provide in your exam. Actually, I'm more interesting to discuss about this. Can anyone can express or can give answer? Oh, my midterm answer is this one because I think like this one. Okay. Kiri, can you translate this part maybe so we can have a discussion about 5 minutes? Kiri?
I think like we have some connection problem, I think.
Oh, okay. Or anyone can try to translate this. Can you help me to translate this in Chinese so we can have a discussion?
Maybe I would tell me.
Sorry, Gary, your speaker, your microphone.
Oh, sorry, because I lost connection earlier. Can you repeat again?
Yeah, that's okay. Can you try to help me to mention this part so we can have a discussion about 5 minutes maybe?
Hey, can you repeat again? Sorry.
Okay.
Which this one, right?
Can you this part? Can you explain this part to the other students so we can have a discussion? Actually, I would like to discuss what kind of answer that they provide in exam, in midterm exam. So
他就是把那个 OK，yes， sorry，so 他就是把期中考拿出来，基本上期中考就是在讲这个耐久性的问题嘛，就是一些相关的措施。那他希望各位跟他分享一下你们在期中考的写的一些答案，就是有没有任何的考量到这些相关的问题，可以分享一下。
Because you don't need to provide what kind of non-destructive test or destructive test did you answer, but just provide me what kind of defects or what kind of deterioration that our midterm case happened. I mean, what happened in our midterm.
Okay. Can you hear me clearly? I'm sorry.
Yeah.
Okay, so in the midterm exam, I think that the problem is the sulfate attack, or maybe the long operation time. So it's make our concrete have some corrosion.
Okay, sulfate attack. And then the other one is corrosion.
Yeah, corrosion.
Okay. The others, maybe they have something in mind. So I think every student have their own answer. So that's why I would like to discuss this more. Because the case, just imagine that the case is our real case. So we should we should imagine what happened to our structure, even though we didn't have any specific data. Okay, so but at last we can know, oh, maybe this kind of defect will happen to our structure, something like that. I think this is interesting to discuss together.
各位还有没有其他的案例可以分享一下？就是基本上透过案例，我们能够比较好的去了解这相关的去进行讨论了。
Or maybe someone write in the chat group, but I cannot see the chat, so maybe Gary can say it.
或是你们可以在聊天室里面打出来。
Suicide attack is good, but before while waiting, okay, while waiting, I will tell my answer. Actually, my answer is about AAR. I don't know why, but something crossed in my mind is about AAR. That's a alkali aggregate reaction. This is something just crossing my mind, like, oh, maybe this one will be happen. And the second one is corrosion. Yeah, corrosion is also come to my mind when the crack happened. Like we have 40 years or more than 40 years old bridge. Okay, I think that will be have some cracks, no matter where is the position, no matter where is it, but there will be some cracks, right? When the cracks happen, there will be some corrosion also, and the crack also happen for the AAR, I think. Another opinion, maybe. If no, then I will just continue. Okay. Yeah. But
so Kevin said, okay, you can check on the chat room.
Okay, wait. I will stop the share first.
So Kevin said she assumed there will be internal crack and like loss protection in the steel bar, which means the steel bar erosion.
Steel bar erosion, or maybe steel bar corrosion, I think. Yeah.
Yeah.
That's quite same. I think that's a typical answer that every student provide. Yeah, that's a good answer. Thank you so much. That's why we discuss it here. So maybe after this session, a professor will tell us, oh, maybe the most important thing that you should aware is this kind of problem. I hope so. Okay, after this season, because yeah, just in case we have same problem, we should be able to imagine how our concrete carbonated concrete. Yeah, carbonated concrete. Yeah, I also write the carbonation actually, but I don't know, is it true or no? But yeah, carbonate is also included in my answer. So I have three, like AAR, alkali aggregate reaction, and then corrosion and carbonation. I don't know what you guys answer, but I hope you guys got a good reason for that. Okay. Now let me continue for my presentation. Wait, I will share my.
我先讲一下哈 ，sorry， 我先讲一下哈，因为我有去看，就是当下用手机，刚好我稍微再看了一下哈。 其实那天要讲，有一些同学我有规定说要画流程图，画什么的哈，把你们的构想写出来。那可能页数很多，可是都没有把构想写出来，可能有一些只是在整理一些相关的一些网络资料哈。我想我分数都不会给大家太低，因为大家很辛苦，可是我还是要有区分哦，区分。所以可能你觉得说你页数很多，可是你都没有把中心思想写出来的，我分数会给的，就是还是会有一点比较低，但是也不会很低啦，所以不用紧张，只是说，我从流程图里面我会先去看构想，可是有些人连流程图都没画只是在整理一些相关的文献那这分数我要先讲一下分数，我不会没办法比别的同学低，但是我想我基本上会从70，可能从80分开始打啦，因为你们都是硕士、博士生，我想我不要给你们那么低的分数。那如果拿到80分的同学，你就知道可能你写的真的不是很好，虽然你页数很多版面弄得很漂亮，可是真的没有内容没有我想要的内容，可能分数会比较低一点。那这部分请同学就是见谅，我还是得要有一个分数上的区分。那至于我看了一下有一些同学写的还不错啦就是说除了这里面我要你们考量的是耐久性的一个问题，因为耐久性跟环境因素有关当然腐蚀是一定很重要的腐蚀问题那桥梁的部分除了这腐蚀的一个问题之外那当然就是其实你们把所有的耐久性的一些化学问题都提出来，我觉得很不错除了这些问题之外，劣化问题不是光只有耐久性包括你们之前学的浅变这些相关会造成裂缝，有这些裂缝就会产生一些劣化的问题，这个有提出来的同学也很不错，所以你们可以就是我看很多同学都会列出来，但是列出来之后你就必须要去思考你要怎么去做这些相关的规划，相关的一个检测其实你们只要找一下桥梁的一个检测的部分这部分基本上会有一些东西都可以把它列入的。那当然我里面希望你们讨论多一点的一些耐久性的问题啦这部分是我自己心里的一个部分。然后再来就是可能你们都没有注意到，就是说有一些东西检测外观形貌的检测是很重要的不是光只有仪器的检测一开始你在规划的时候，你应该可以先强调初步的初勘就是我们基本上我们在外面应该是第一个就是你第一个先去踏勘嘛，踏勘之后你再回来规划，你可能会发现这个问题可能会呈现哪些的问题我是希望同学这样子，但是没有标准的答案，说我会看同学的构思去打分数，那也不用紧张，我都最低就从80，但是确实有一些同学连流程图都没画然后只是页数很多，但是内容我觉得就是没有去整理这部分我大概心里自己有个底的啦那这部分我可能会各自给分数各自跟同学讲你的分数是多少然后当然就是说你们平时的一个讨论像上次在那个我到最后平时的你们团体的分数我会给你们那你们各自的这个报告的分数我也会私下给你们，只有团体的会公布这部分那大家也不用紧张，因为你们都很配合，而且在这种实习的话，我想分数我都不会给太低。那至于书面的部分的话我们再看最后因为看起来书面连考试的机会到底有没有是一个问题啦。如果没有考试的时候，那我们是不是分数再做个看怎么样子去平衡就是说你们现在报告加上期中考加上小组讨论怎么去平衡，有可能书面我猜书面考试的几率可能已经变低了，因为看起来会在延后就是这个疫情的关系好，那我只是刚好突然想到说他讨论这个的时候，我要跟同学讲一下我在打分数的一个想法这部分可能就是会把期末考的分数再加一些在期中考的分数上面去啦，然后再一些分数拿到平时的讨论里面去好，那我只是讲一下我的评分方式而已，跟同学报告一下
Okay, so Professor say let's speaking of which for the midterm exam, so she's going to tell how he going to score your midterm exam. So yeah, so Professor say she mentioned many times there should be a flow chart, And for those who didn't, because the flowchart is how you express your idea, how you're going to design, how you're going to design the project. So if you didn't, then maybe you'll get a lower score compared to the other people. And the score for the midterm, you will be starting from 80 to the maximum 100. So if you get 80, then you probably know like which place you lies into, because some people they only put so many literature review into your project that you didn't walk through about your idea, how you're going to how are you going to continue your project. And for the closed book midterm exam, for now we still stick to the plan. Like if in the future everything goes well, then we will have the closed book one. But if it's not possible, like the situation still remain the same, then maybe there will be no closed book. Just maybe we'll have to discuss in the future, but just maybe. So if there's no, there might be some different alternative. Like maybe the open book one percentage will be raised, and also the general discussion of in the daily courses the percentage will also be increased. Okay, that's one solution, but we still have further discuss in the future.
Okay. Well, thank you so much. Now, I will try to continue my presentation. Okay. Yeah, this kind of deterioration that will happen to our structure in the coastal zone, like maybe like a same case like our midterm case, right? I get it from the doctoral dissertation, but I didn't get the reference. So there's this one is when our bridge or reinforced concrete bridge is attacked by the sea wave in the winter season. So when the winter season comes, that the wave may be more bigger than the usual, that will make our structure got sway or got swept because of the sea wave. Okay, and then the second one is the surf rebar corrosion in a coastal region. That's why I want to discuss just a little bit about our midterm case. Just want to know what kind of defect that maybe happen to our structure. Okay, and then a large amount of daishing salt accelerated rebar corrosion in a reinforced concrete bridge slab. Okay, next we're talking about leaching and efflorescence. Okay, efflorescence is occur when water can percolate through material, even or either it continuously or intermittently, and then that will occur also when exposed phase is alternately wetted or dried. This kind of something like cyclic or cycle wetted and dried, and that happen again, happen and then repeat it again. That's why the efflorescence may occur. You can see from this figure actually. I make some red circle. This is the off-white crust of calcium carbonate. Okay, this one is a efflorescence visible below the concrete decks, I think. And then for the efflorescence itself, actually that's not a durability problem, but that's a aesthetic problem. Not for physical actually, but just for like is it good or no, something like that. But actually, the efflorescence it may indicate that substantial leaching is occurring within our concrete. So efflorescence actually not talking about the durability, that's kind talking about the aesthetic. And then that also can be indicating something happened in our concrete. Okay, what is the cause of this? This efflorescence? Okay, the first is porosity is high, and the second one is our concrete strength is decreased. Another one is because the permeability increase. And then this one will be lead to the vulnerability to aggressive chemical. You know, when this is happen, that will be lead to the aggressive chemical, or that will be very vulnerable to the aggressive chemical. Okay. And then this is for sulfate attack. Sulfate attack is chemical action between product of hydration and then the solution that containing sulfate. Okay. Right. And then for the higher concentration of sulfate in the groundwater, generally because of presence of, because of presence of magnesium, and then sodium, and then potassium. Actually, the sulfate attack, this sulfate attack will lead to the degradation of structure. Okay. What happened? That may be happen is expansion and a cracking to the concrete. Okay, and then that might be happen also is a progressive decrease in the strength and loss of mass. You can see that this kind of picture I got it from Metha, I think. Yeah, this is a concrete post damage near the soil line by sulfate attack. Okay, you will see this kind of part. Yeah, just above the ground level, the sulfate attack happened. Okay, and then this kind of chemical reaction that happened in the sulfate attack. Okay, for the general agreement, actually, sulfate is sulfate-related expansion. Okay, that all associate with the ettringite. This is the general agreement of the researcher. But you know, in Metha, I think it say that this is still controversial. Some hypotheses from the researchers say that that might happen because of exertion of pressure by growing ettringite crystals. And then the second hypothesis is that happened because of swelling due to the absorption of the water in alkaline environment that make poorly crystalline ettringite. Okay. This is for gypsum formation. Actually, deterioration of the PC or Portland cement paste is by gypsum formation lead to the reduction of the pH. This one, reduction to the pH of the system, and then loss of the stiffness and strength. Okay, and then followed by the expansion and the cracking. This will happen next. Okay, let's talk about the gypsum formation next. Overall, sulfate attack may be considered as a consequence of three processes, as you can read in my PPT. Right, this is for the first process is diffusion of sulfate ions, and then after diffusion of a sulfate ion, that will be a control. This one, the sulfate ion is controlled by the permeability. Like I said before, permeability is an important factor for the durability problem. Okay, and then for the second one is the gypsum corrosion. Okay, that may be beneficial. Why? Since gypsum is more soluble. Okay, gypsum is more soluble than calcium hydroxide. That will allow gypsum to first to crystallize without expansion. So this one is yeah. for this one. And then this may explain why sulfate attack on cement phase with little or no C3A take a decade. So actually take a longer time rather than take a short time to occur. And then for the third one is a sulfo-aluminate corrosion that will be lead or causing the internal cracking. Okay, thereby accelerating the further surface attack. Okay, similar behavior is also affected for cement with a low C3A content, which is subject to the sulfate attack. But however, this is important thing is, however, the time over with the surf expansion occurred due to the attack on CH. This one, it should be highlighted. CH and CSH. That will be extended compared to the cement height in the C3A. This is the third process that should be considered of the sulfate attack. Okay. Okay. In Metha, actually, to control the sulfate attack, in Metha describes some PRA teaches. I think that's kind of something like standard code. Okay. Actually, I have the file. If you guys want to learn more, I have the file and I can send it to you. But the special digits is in a 2005, I think. The code is quite older. According to the PRA digits, factor influence sulfate attack are this kind of factor. We have 5 factor. Okay, the first one is the amount of nature of sulfate which is present in the concrete, and then the second one is the level of the water table and its seasonal variation. Level of water. And the third one is the flow of the groundwater and the soil porosity. Okay. And the fourth one is the form of construction. Actually, the form or the shape of construction is also related to the, or that also influence to the sulfate attack. And the last one is we also talking about this before, like quality of the concrete. This is also influencing the sulfate attack. Okay. If the sulfate water cannot be prevented, so what should we do? That's a big question. Like, we cannot prevent the sulfate attack. The attack will be happen. So what should we do? We can just control the quality of the concrete. That's an important factor in this discussion, to control the sulfate attack. Okay. Okay. For the effect of cement type and the fly ash addition on sulfate attack in concrete, let's take a look in. Actually, sulfate attack, like I said before, is controlled by cement content, and then cement type, and then mineral admixture. Actually, I want to discuss more about this later, but yeah, let's talk about this graph first. When the permeability of concrete is decreased and the content of cement is high or increased, this should be happen for the deterioration because of sulfate attack. Okay, let's see this. The average C3A content in every cement type is different, right? Now, let's take a look for the cement content. Take a look for the cement content. I think for the same scale, like same C3A content, that will be higher cement content will be have lower deterioration. Okay, this one, higher cement content, because this one is a small, the intermediate, and this one is a small one. So to create a good concrete structure to resist the sulfate attack, we can create the high strength concrete maybe. And then let's see for the this is the if we didn't have this kind of C3A content, like a certain cement type, we can variate the composition actually. Like we can add the mineral admixture like fly ash. I think this is from the previous research. They try to combine fly ash with the C3A with a certain percentage. Which one is better? Actually, the better one is if we have like this kind of, oh sorry, I think the better one is this one. Yeah, I think this will be lead to the sea, lead to the sea. So we have not too much expansion per year, percentage per year. Okay. I will discuss more about this later with uh, some of writing of mine already provided before. Okay. To control the sulfate attack, actually we should have the low permeability of the concrete structure. Okay, and then we should have the adequate concrete thickness. We should have a high cement content, low cement water ratio, and then proper compacting and curing of the concrete. To mitigate this kind of effect, actually, we can provide another additional safety, like we can provide like sulfate resisting Portland and the blended cement. Okay, so for the Portland cement that containing less than 5%, this is typically for cement type type 5. It is sufficiently for resisting under moderate condition. This should be highlighted. This is a moderate condition. But however, for the high sulfate concentration, this cannot be applied. This should be aware by every student maybe. High sulfate concentration, we cannot control the sulfate attack, but yeah, we can just to minimize it, I think. Okay. This is the sulfate exposure classification of the severity. Like we have four classification. We have a negligible attack, and then we have a moderate attack. We have a serve attack and a very rare, very serve attack. If you guys interest more in this classification, you can read this part. Actually, I have the ACI. If you want to read more, I can send it to you later. Okay. Now, this is for a delayed extrinsic formation. Actually, DEF occur after the concrete is hardened, and that can occur when high elevated curing temperature happen, like above 65 degrees Celsius. And then that also can occur when sulfate and aluminate content in cement at a potassium level. You know, potassium level is like the rose level, like the rose level. Sorry. Yeah. Sorry. Rose level. Okay, and then the DEF also we can say that DEF happened based on this researcher. I think Cleo Pardy is a researcher that gave some approach to the DEF because of to make not to make but high permeability occur or happen because of this factor. Okay, and then DEF also can occur because of the presence of water, and then this is the most important thing, I think. DEF also can occur because of gypsum contaminated aggregate or sulfate releases from the CSH. Okay. This is another test for the sulfate attack. We have the ESTM C452, and then I think we have two ESTM standard to test it. But actually, this ESTM is just for research, not for the practical issue. Okay. And this one is for cement, just for cement, not for concrete. And then also this kind of test, it takes too much time for the routine test, so it's not applicable in the practical issue. And then the test is used only with the PC and with this one is a Portland cement, and not to assess the behavior of cement that blended with the pozzolan or slags. Okay, I will tell you why later. And another one is ESTM C1012. That's designed to provide the means for evaluating expected. I'd like to highlight the expected because this also cannot be a good judgment to say that our sulfate attack, our concrete structure is attacked by the sulfate or not, but this just for the evaluating. Okay. So this one I told you before, for the alkali aggregate reaction. Oh, sorry. Is there any question, or I should keep going? I forgot about the time. Any questions? Is there any question? If no, I will keep going on.
I think it's okay.
Okay. I will keep going. We were talking about the alkali aggregate reaction. Like I say in my PPT is this is the process. Okay, alkali plus hydroxyl ions, which is lead to the expansion and cracking. Okay, expansion and cracking. What happened for this kind of deterioration? This will be leading to the loss of the strength, loss of the elastic modulus, and then all of this process could be happen for alkali silica reaction. I will talk about this with this PPT. Okay. I would like to show you my. Okay. Yeah. Can you see my PPT? Oh, sorry, not PPT, but can you see my screen?
Yes, I can see your screen.
Okay, thank you. Now, let's discuss how to prevent ESR. Actually, I would like to discuss more about that. So, the ESR, alkali silica reaction, is happen, but as as an engineer, we should be able to stop it or to prevent it. Why? And how we could prevent the ESR from happening to the new concrete. I would like to highlight this kind of new concrete, okay? But we cannot prevent the ESR after the concrete already hardening. So yeah, this is the prevent action, okay? The first one is take a look for this triangle correlation. The first one, we can use non-reactive aggregate. Okay, non-reactive aggregate. What kind of aggregate is that? So actually, we can taste the aggregate with ASTM standard. What standard? What ASTM? The ASTM used is the C1260, and the second one is C1293. But actually, from what I read before, these two kind of standard testing is really time consuming. So that's not really practically actually. The most common method that we can apply to our aggregate tests should be field performance test. Okay, but all of this testing and to prevent the ESR happening in a new concrete, this kind of way is not too practically. Okay, so most of researcher will be discuss about how to lower the pH. This one is a common technique or common method that researchers usually do to stop the ESR happening in a new concrete. So they will do the decrease alkaline loading. So how to decrease the alkaline loading? Actually, we can design the proper composition before create our concrete, right? So use the minima cement, or the second one, you can use the SCM. What is SCM? I think SCM is a supplementary cementitious material. This is what we call like furnace slag, what we call like fly ash, something like that will react to the silica. And then the other one that we can do before the construction process to prevent the ESR in a new concrete is we should pay attention to the water. Attention to the water, okay? We should decrease the permeability. How? We can make water cementio become low, okay? And then we can try to make a good curing, and then we can have a good consolidation, or even we can have a SCI also to decrease the permeability. Okay. And then yeah, this is the picture that I got from Metha actually. You can get it from the PDF. Alkali silica reaction may become one of the causes that destroys the structure. Okay, this kind of ESR is because of the long surface life. I think that will happen. The SR usually create some crack that have a form like a map or like alligator skin. You can see this kind of crack. Okay, and then the second one is for the reinforcement concrete that usually parallel to this one is the contributing of ESR to the deterioration of the concrete. This is the case that I got from Metha. This is the several concrete dam structure. Okay, Okay, this is for the expansion. This is the name of the dam. So every dam has their own expansion. This depends on the high alkali cement or low alkali cement. What is the parameter of the alkali cement? Actually, we got 0.6%, more than 0.6% that should be stated as a high alkali cement. Okay, and then for the low alkali cement, that should be lower than 0.6. Okay. Yeah, how to control the expansion? I think this is also important. Most important factor that influencing alkali aggregation is we have 5 factors. As you can see here, we have 5 factors: that alkali content of the cement and cement content of concrete. So this one is the first factor that influencing the alkali aggregation. And the second one is the alkali ions. The third one is the size, amount of size, and reactivity of the alkali. And then the fourth one is the availability of moisture to the concrete structure. I think the last one is the ambient temperature. Okay, so the best way to protect our structure from alkali attack is I make the highlight here. Maybe you can get the point from here. Okay, use the low alkali Portland cement, or if you didn't have that kind of Portland cement, so you should be use your material. In case you use the C material, you should wash your material with the sea water to ensure that the total alkali content from cement does not exceed 3 kilograms per meter cubic. This is the best way to protect our structure from the alkali attack. Okay, this one also almost same with I explained before. Like if we have an alkali in a concrete, that should be we can reduce or replacing the alkali content in concrete with the cementitious like SEMS. Okay, this one I told you before in the previous PPT. Okay, please remember this kind of method is actually we can achieve less expensive products, if I can say that, less expensive product, and then we can have a high silica ratio also in this kind of technique. Okay, so this one is just for the hydration of crystalline NGO and CaO. I think this is not really important, but for this kind of crystalline, you should remember that ASTM already have some standard that the NGO content should not exceed for 6%. Okay, this already described in the ASTM C150. Okay, this is the last part of my presentation. Crystalline of salt. I will finish my presentation maybe after this. Okay, if we have a high level of salt and then we have a high rate of evaporation, that will be causing a problematic acute. Why? Because if you see this picture, okay, this picture, I take it from Metha, maybe from the previous PDF of Metha. you see this zone, this tidal zone. Actually, this part is always sway out or swept by the seawater, okay? But the seawater have a fluctuate, right? That's depend on the wind or and then the temperature, right? Actually, this will be lead to the problem what we call crystallization of the salt. Okay, and then what is the best way to prevent or maybe what is the limit the problem of the salt crystallization? How to prevent it? Maybe how to reduce that impact? We can use as I write here like low water ratio that will be low for permeability concrete. And then we can try to sealing the concrete. We can add another layer of concrete, okay? And then we can build a barrier into the structure. And then we can try to improvise clay fill. This is for the underground concrete, not for the coastal structure. Or we can make a sacrificial layer of moisture, like I said before. We can add another layer that will happen for the crystallization of salt. Now, give me 2 minutes to explain this one. This is my research actually, like I promised before. I will talking about the special topic. This is my experiments before. We investigate about the seepage in concrete. How we do that? We do that with the RFID ultra high frequency radio frequency response. Like, yeah, this is my samples before. We have a smart tag, what we call smart tag. Like we have a RFID tag that can provide the data inside the concrete. Okay, and then we create the this one first is a socket. Okay. Before socket, usually in our experiment, we create the crack so the water can penetrate into the concrete. Now, this is our tag, smart tag, our RFID tag. We call it moisture tag. So it can detect the moisture inside the concrete. And this is what we got in our reading experiments. We got the SSI. This is the signal strength, and then we got the frequency, and then we got the sensor code. This one for the moisture parameter. Sorry, yeah, for moisture parameter. Okay, and then this is our paper that already published last semester, I think. Okay. Now for my research, I will do the same thing with different condition of my concrete. But actually, right now I'm still studying what kind of differences between the previous research and the upcoming research. I think that's all. Thank you so much. Sorry for the time.
辛苦了哈 ，Thank you, great.
Sorry for the time.
我要问同学问题哦，因为我觉得就是可能 Alan 准备的非常丰富啦，只是说可能时间的部分，我觉得以这样子的时间是按照我们以前是这样子的时间是 Alan 这样子是很 OK 的。那可能在这边的话，到后面可能同学因为我们没有下课，大家都可能就是比较累一点那没关系，让我们来。我想问同学几个问题，但是我觉得 Alan 表现得很好 ，Great， OK， 好，那我问同学，那个郑凯再帮我问一下，就是说跟膨胀就是他们听到现在，还有你自己知道跟膨胀有关的 有关的几种化学反应，可以跟我讲一下？就是问同学，就是这些化学反应所造成的混凝土裂化，跟膨胀有关的。膨胀就是膨胀之后才会造成混凝土的裂化嘛，对不对？那也是化学反应造成的，可以跟我举例几个吗？让我们点同学咯。那个我就是刚还没点过的，我点一下一凡好了，你帮我问一下一凡。
Okay, Ifan. So the professor asks you, so when it comes to the chemical, with the chemical in the durability, what's the 4 factors or like four kinds of reason will affect in the chemical durability? So in the expansion.
Expansion 对
Yeah, especially in the expansion.
Yes.
然后他说他可以用打字回应吗
OK.
I think because Ifan still have some problem with the health. Yeah, that's okay. Mm.
因为我们现在就大家可以起来动一动了哈。那我等一下会再跟同学讨论说要继续，还是说带米再延到下礼拜，还是说因为礼拜五哈也可以再看看。Yes 哈，李玉央讲。好，那个我本来是要问那个一凡，然后那玉央他们都有帮忙讲了哈。好，这个膨胀 expansion 的这个问题里面有包括，譬如讲说真正的血，对不对？因为膨胀才会造成一些裂化问题，就是钢筋腐蚀，钢筋腐蚀的问题。那钢筋腐蚀的这个问题的话，可能我看了戴迷和那个Alan 这边都没有讲到，可是我们上次有请人家来演讲，有稍微讲到。然后最后如果还有時間，未来还有时间的话，我可以再另外再讲一下啦，就是钢筋腐蚀的问题。然后刚才讲的碱骨材反应，就是 alkaline aggregate 这个这个问题，还有硫酸盐侵蚀，硫酸盐侵蚀那个英文我念得很不顺，所以我就不念了还有呢，刚才那个 Alan 有讲到啊。氧化钙、氧化镁也会啊，氧化钙有没有？你们常常会听到游离氧化钙、氧化镁，这都会造成体积的一个膨胀。那我看一下一凡不是一凡那个 Alan 的简报我稍微说一下我稍微说一下好了，就是钙反史，我会希望你们去了解。那钙反史里面，它有讲到一个叫做DEF 就是延迟的钙反史，延迟的钙反史。好，那我现在问同学，就讲出来没关系，你们试着回答我想说，我们今天用讨论的来收尾啦，收尾。然后戴米都大概稍微接一下下礼拜或者是礼拜，我们等一下再讨论就是那个你要讲的东西，让大家回去准备一下。我觉得不错啦，就是说用讨论式的方式硫酸盐其实我大概讲一下概念，那个阿凯，你就是比较快的帮我稍微说明一下硫酸盐其实就是说我们跟什么有关？你看那个 Alan， 我看一下他的简报第几页。Page 39。你看我先讲一下，就是说，当然硫酸盐侵蚀最重要的原因是跟我们水泥中的什么东西，哪一个化合物成分很有关系。我问一个同学，刚还没问到是谁？明玉还没问到吗？明玉有问到吗？明玉 ，Hello。
老师，嗨。
就是硫酸盐侵蚀跟我们水泥硫酸盐侵蚀一定是水泥的问题造成的，跟我们水泥哪一个化合物成分很有关系
？CaOH。
化合物。我们有4个主要化合物吗？
老师是说水化产物吗？还是？
不是化合物，当然不是化产。
CaOH2 不是 C 还是 C3A？ 老师讲，
我听到玉央讲了哈，是 C3A 哈，那这跟水泥的这个部分哈，这个部分的一个生成有关哈。那当然它们结合，当然你讲的也对，就是说跟水化产物里面的一些关系哦。它在我们添加一个石膏量的一个部分哈，添加量的一个，我们不是有个莫尔比吗？哦，这当然之前这是上学期的哈，就是说我们水泥哦，因为会有闪灵的问题。所以我们必须添加石膏，让它什么？让它就是不要产生闪灵的一些相关问题。但添加量有一定的限制，添加量不足的时候，可能会形成的就是包括单硫型铝酸钙跟钙矾石，对不对？但是如果你在这边有时候是水泥的水化的一个过程中，那生成就是钙矾石，它没完全生成钙矾石。我只是很简单的讲哈，很简单的讲，但等一下我的手机在响，先没关系哈。好，我先讲，就是说，它如果生成的是它等于说这个水化钙矾石的生成，我就不要特别讲一些相关的一些因为可能那个他们之前水泥雾化没有特别的修过哈。那我是讲说延迟的钙矾石的一个部分，就是说它单硫型铝酸钙，我想。它是几个结晶水？
老师再问一次，是
断掉？
刚才断掉。
我是说，如果是形成单硫型铝酸钙，那单硫型铝酸钙它是几个结晶水
？32个。
不是哦，
不是8颗结晶水。
基本上它是12个结晶水。
12。
等一下，它是12个结晶水。那如果在延迟，就是说我们在水化过程中硫酸根离子的一个去结合，然后当然你要注意这些都是跟什么有关？跟水有关，有水。然后呢，在一个有硫酸根离子的一个硫酸盐类的一个环境，譬如讲工厂或者是海水里面，它会让它形成一个低密度的一个钙矾石。那这个钙矾等于说单硫型铝酸钙又形成了钙矾石，它又形成了几个结晶水，但是是低密度的32个结晶水，所以它体积会长大，体积会长大。那体积会长大，这就是我说的引起一个膨胀的一些相关问题。那我要讲的就是另外一个，就是我自己本身的研究的东西。你们看到39页。好，39页我要问问题了39页它是说控制你有没有发现一件事情？这就是要给明玉看的39页page 3939。好，然后呢，你会发现为什么在海岸结构物它会希望你用5型或2型水泥？因为海水里面有这些相关的盐类氯盐、硫酸盐，有没有？那二型水泥其实它有去控制2型或5型，它有去控制铝酸三钙的一个含量。这是第一个，就是说我说它其实跟铝酸三钙的含量其实是非常有关系。所以 Alan 这边不是有写水泥的含量，其实应该是说这个化合物成分，水泥化合物成分的含量。那这个含量跟什么有关？跟当然是水泥的形式也有关。那这边可能我没有这边我要特别讲一下这个 mineral admixture 这个他写我刚才没有仔细听，他写下降的原因是什么？会造成吗？造成硫酸盐侵蚀吗？你可以帮我问一下吗
？Okay, Alan, the professor asked about the mineral admixture over there. So why does it decrease? Can you explain again?
Why? Oh, not decrease actually. That's a minimum mineral admixture. Like we should use the small content of mineral admixture. Not decrease, but for use the minimum value.
which means like if you add too much, they will be the soft-like attack.
Yeah.
然后是说，就是为了要避免这个硫酸的侵蚀，要
Yes
降低那个矿物参料的比例。
我课本是这样写吗？
So is that inside the textbook?
Okay. Let me see. I think I get it from the Metha. I think.
From where? So,
Yeah.
from where?
page Meta 第几页 ？page
Wait.
我看他说167，五字。So which page in the Meta?
167.
167页。
等一下，我看一下。
Wait, I will take.
你们查一下哈，我解释给你们听，就是我不知道你们要看那个，你们帮我看一下 page， 就是 Meta 的167页，它是怎么说的？因为呢，在海岸结构物，其实它会希望哈，除了用2型，我等一下学长可以补充一下哈。2型或5型的水泥哈，第一个它是中度抗流，主要是因为它有限制铝酸三钙的含量，然后它水化热低。它水化热低的话，这样子的一个生成，可能会比较不会有一个热裂缝。然后再来呢，有一些会在里面加一些矿物参料，跟我Alan 讲的说降低，就是不要让矿物参料那个下降。我不晓得它的矿物参料是什么，因为有一些人会加矿物参料增加它的致密性。你听得懂吗？因为矿物参料我们是要增加它的致密性，让它渗透更惨，因为就跟水有关嘛，跟水有关，如果水容易进去反而更糟，所以应该是在这个海岸结构物或者是在预防硫酸盐，其实用矿物参料其实是好的所以我才会看到他这边写说反而不要用矿物参料的意义是就是下降是什么，所以你们167页他是怎么写？你们有人查吗？
有老师等一下还在跑。
Okay, so Alan, the professor's question will be because in her experience, like usually because now we're talking about the Soviet attack, right? So we're talking about the marine environment, which is near the sea and near the ocean. Okay, so in this case, usually you should be in her experience, you should be adding much. Not much more. You should be adding the mineral admixture, because that can give you better compaction, like a more lower permeability, because the mineral admixture can give you stronger, we say the compressive stress.
Yeah.
So in her experience, you should not decrease the mineral admixture. So how did the textbook say about this part?
Oh, okay.
我只是在讲，当然不能加太多，加太多也不对。那有一些在海岸结构物，为了避免这些氯离子的渗透，其实它们的原理都是一样，就是让混凝土孔隙更致密，所以是会加矿物参料的。那所以我不太晓得降低矿物参料这个意义是什么。那个学长在吗？
我有在。
对，那你的看法呢？
没有，书上讲的很像是说，因为加的矿物参料可以降低C3A 的量嘛，所以它可以抵抗那个腐蚀。书上是这样讲，可是这个的话，我的看法是说，如果把那个150那右边那张图150的那画条直线，那1:2的话。那个量会比较低一点，是不是这个图的解释？
其实这张图的基准是不同的，这就是我说你们在比较的时候，我先讲，如果今天要比飞灰，就是 fly ash 要比 fly ash 的话，他们应该是在控制同一个基准下，什么基准下？铝酸三钙要同一个 percent，
对，就是对不起老师。就是那个，比如说我画在150公斤那个位置画一条直线，就是1跟2的那个量啊，膨胀量嘛，那它的比例刚好一个是40，一个20。
但是我说它基准不对，为什么？因为1 它的细酸铝酸三钙是7% 然后 2 的这个部分它是9%，所以以这里面影响最大的应该是铝酸三钙。它这两条线在比较的基准是不对的，你听得懂我意思吗？
我说会不会是因为它取代水泥量比较少，导致它的铝酸三钙比较少？
所以我不晓得书上是怎么写的。
越多它量越低啊，C3A 越低啊，这样图是对的。一的取代量比较高，所以它降低了。
是没错，对，那没有啦。我的意思是说，为什么他这边是写说它的下降 mineral admixture 下降 decrease 是代表什么意思？167是怎么？
这个不知道，我是讲书上的，书上这样讲是对的。
你说书上讲的是对的，所以
就是
书上是怎么讲？因为我还没去查书。
就是那个什么，等一下哈，书上讲的是说那个飞灰取代量越高的时候 ，C3A 越低嘛。
所以它成效越好嘛，对不对？
对，效果越好。
那是啊，这个跟我刚才讲的理解是一样，所以可能 A 人这边的下降我不太知道意思啦。嘿，好，那我只是要去查证一个答案，那就是这样子。那我大概了解了哈，就是说
他的解释我不太。
对，可能 A 人这边再厘清一下，因为这个他画的这个箭头让我误解了。那基本上因为你说他这边是说应该是说取代量越高，铝酸三钙它应该是会下降。那取代越高的话，但是也不是无限制的哦。无限制的话，反而你取代越多的矿物参料矿物参料取代越多的水泥，不一定效果就一定是很好，它还是会有一个下降的一个部分最大取代量所以来我大概跟同学讲，硫酸盐侵蚀的话的控制因为 Alan 在这39这一个 page 39这一个部分有 cement content 这个部分，它最主要是说铝酸三钙C3A 的 percent 应该要 decrease 最好是下降。那什么样子的东西会让它下降呢？第一个，我用2型或5型水泥，因为那有限制铝酸三钙的含量这是第一个策略所以这边你看那个它的左边的图这边很明显就可以看得出来。第二个，我用什么？我用捕捉蓝材料去取代的部分，也会发现取代越多的时候，我铝酸三钙也会下降。但是你要知道 mineral admixture 的话，它其实是可以让混凝土孔隙更致密，它等于是双重，第一个降低了铝酸三钙，第二个它又让孔隙更致密，反而是更好的我只是好奇那个下降，我想说奇怪图怎么课本的解读跟我们的讲的不一样，所以我才去查证。好，那没关系，我觉得 OK 啦，这边再大家讲清楚就好了。那我们等一下把它讲完之后，我们再先下课啦那个郑凯，你可以跟大家讲一下吗？就是说这个控制的一个部分，从图上来刚好解读。
Okay, so what the professor wants to discuss in this picture, so still on the right one. So there are 2 ways to decrease the C3A content. The first one will be changing the type of the cement, right? So if we, let's say if it's near C, so we use type 2 or we use type 5 cement. All of cement, they have lower C3A content. Okay. And the second one will be maybe is in this picture, which they use the fly ash to substitute for some cement component. So if you put much more fly ash, then of course you will have lower cement, so which lower the C3A. Okay, so now everything is clear. But for the mineral admixture, so professor would like to double check, maybe to tell us in the next week.
Sorry, I think actually I made some mistake after I read through this graph. I think I made some mistake. Maybe I made some mistake. Yeah.
他说他确认他可能看错了，他重新读过后。
After I try to draw
我才会。
Yeah, maybe I made some mistake. So sorry about that.
OK， 好，然后再来就是他在讲碱骨材反应 alkaline aggregate reaction 这一个部分那这部分我先我用一下我的很简单的简报哈，我等一下哈，我应该可以。但是我先用这个是中文的啦，因为很临时我没有再翻成英文。那阿凯你再帮我那个跟大家讲一下，就是我的碱骨材反这个部分那这部分我有看到吗？
有。
那这个部分不是我先讲一下因为我想说现在都大家在学习，我先跟同学讲一下，就是说我看大家也很累了我们就是今天把这个耐久性的部分稍微讨论一下。那戴米的话，如果礼拜五一凡他要去看医生，我们就那个，然后等于说下礼拜三我们不是有2节课，礼拜1点到3点吗？再继续那个戴米把它讲完，这样可以吗 ？OK 吗？
Professor say that she thinks that everybody kind of tired today. So because our original schedule, the junior Daimi will have to continue to present for another 2 hours. So maybe she can skip to the next Wednesday. And next Wednesday will be 2 hours, right? Because this Friday, Yifan have to go to the clinic to go to the doctor. So we just skip this Friday. Okay, so.
对，最主要是怎么了
I'm sorry, Professor. So Demi will do the presentation Wednesday this week or Wednesday next week?
他是sorry, you mean you or the junior?
Demi.
Demi. Next week, next Wednesday.
I'm sorry. Next.
Sorry， 我跳出去了。嘿，那个我会先就是等一下，我怎么跳出？有看到吗？有看到我吗？
有，老师有，你在里面。
好，那个我下个礼拜是那个 Hugh 嘛那戴米这部分。因为礼拜五的关系，戴敏这边跟今天讲的还是他最主要是讲一些那个肌理的一个部分我想就是还先让 Hugh 按照他的进度，然后戴敏再衔接着看礼拜三能不能衔接，这样子可以吗？礼拜三的话，我们就是包括戴敏把它讲完。
对，等于是礼拜三2个人就对了。
不是我们礼拜二啊，我们礼拜二不是要上课，礼拜二就是 Hugh 啊，Hugh 是那个
礼拜二
对，哎呦。会讲礼拜二那 Hugh 如果礼拜二他2节课觉得不够的话，礼拜三继续，然后因为礼拜三下午后面只有2点是那个学长要上课，我们没关系啦，学长这边耐久性这边应该也很 OK。然后那个我看他们都有录影，你也可以看录影。我想就那个，因为最主要是礼拜五下午那个一凡要看医生，还是你们要晚上？我知道了，没关系，我们现在非常时期就那个啦好，那我们就先这样 OK。
Okay, so Hugh, you'll be on your old schedule next Tuesday. You just continue.
Okay.
So if you cannot finish, then you can continue on Wednesday, and Daimi will be continue after you finish.
Okay.
好，那我们今天就稍微讨论一下，我要讲一下那个 AAR 的部分那这个 AAR 的部分我很快讲一下它是虽然是叫 alkaline aggregate reaction 就叫 AAR， 事实上它其实不一样的反应不一样的反应那基本上课本讲的几乎都是 alkaline silica reaction 那 alkaline silicate reaction 的话，其实在一般的一个检测的部分其实很难跟氧化系去区分，所以其实氧化系的反应跟细酸盐的反应，其实很多国家就把这2个当作是同一个再去检验事实上反应行为是不一样，可是很难去区分。那另外一个叫做碳酸盐减碳酸盐的反应，这个部分是在哪里不一样呢？好，我先讲一下，这个叫做简称叫做 这两个现在都简称叫做 ASR 哈 ，ASR。然后减碳酸盐这个叫做 ACR。在哪边不一样呢？在石头不一样。为什么碱细酸盐反应？因为它用在细质骨材。碳酸盐反应是在哪里？在碳酸盐骨材。所谓的碱骨材反应，就是因为石头发生了问题。我简单讲，就是石头发生了一些问题。什么问题？它的键解出问题了。譬如讲说，这个骨材里面它不是有二氧化硒吗？它有2个键解，细氧键解。那我们基本上细氧键解这个键解其实是很强的，所以是很 OK。我们基本上石头不会产生碱骨材反应。什么样的情况之下才会产生碱骨材反应？就是这个键解很弱，特别是在键解就容易被打断，这种就比较容易产生碱骨材反应，就是我说的，有听到吗？有听到吗？
有来了，
有。
我刚才跳开了，是不是？
对。
哇，好，那等于说白讲了，嘿，好，我刚才讲到哪里，你们就跑掉了。
老师让我翻译一下 ，OK 吗？那个。
好。
Okay, so basically the alkaline aggregate reaction, the AAR, can be separated into 3 different kind of reaction. So you can see above. So there are the ASR, the alkaline silica reaction, and alkaline silicate. I'm not sure if I pronounced right. Silicate reaction. So actually these are 2 different kind of reaction, but in general, it's really hard to separate both of them. So usually in most of the country, we just consider them as ASR, which we just consider together. And the other one will be the ACR, the alkaline carbonyl reaction. So what's the difference between this one? Will be the foundation of the aggregate. So of course the ASR, because there's a silicate, which means the aggregate is made by the silicate aggregate. And carbonate aggregate, of course, so it's from the carbonate. Okay, so that's the biggest difference between them. So what kind of situation, how will this reaction start? Will be because the bond between the aggregate have been, we say, disappear in different kind of situation. Like we said earlier about which you mentioned, yes, all kind of possible reaction, which the bond break, so cause the following reaction. 老师继续。
所以我是讲到这3个嘛，那我有讲到石头的问题吗？
老师你就说他们是不同石头，然后它的电解断掉，到这边。
那这样有看到我的简报吗？
老师你可能要放全萤幕。
我现在是半萤幕，有看到吗？没有。
有这样有。
因为我发现我用全萤幕，然后特别是用了画笔，好像它就会断掉。那我不用画笔了。我再试看看好，我再试看看啦因为不知道为什么会这样子。然后呢，喂，
可以，老友
可以然后这2个其实很难去区分，所以在一般国际间都把它就是一起统称叫做 ASR ASR。好，那下面这个叫 ACR。那 ASR 跟 ACR 其实碱骨材反应 AAR 你看它 AAR 第2个 A 就是 aggregate， 所以它是石头的一些相关问题。那基本上一般的石头不会产生这个问题，是什么样的石头才会产生呢？就是 ASR 最主要是它的细氧键解力很差的时候。有听到吗？有听到
有。
好，那细氧键解，这键解很差的时候就很容易被打断很容易被打断，然后被碱金属离子去取代，形成了什么 CS， 不是形成那个胶体就是碱骨材的胶体。那 ACR 就不一样了 ，ACR 不是细氧键解ACR 是因为石灰质的石灰岩里面含有一些粘土，那粘土吸水之后很容易产生膨胀造成的。那基本上这个行为我们比较少看到 也有大陆很多 ACR 反应那我们台湾大部分看到的都是 ASR， 很多都是 ASR， 所以你会发现很多人在讨论的大部分都是 ASR， 所以你看课本这边我也大概就简单讲一下，课本讲的其实都是在讲 ASR 那但是它都是用 AAR 来简称，那我就大概简单讲一下 ASR。好，
老师稍等我一下。
好。
Okay, so 那个忘记了，对 ，so the reason for the ASR and ACR they are completely different. So as we mentioned earlier, the ASR is basically on the bond between the silica and the oxygen, which they break, so cause all those kind of reaction. So the ASR was based on the break of the bond. Okay, but for the ACR it's different. ACR is like in some aggregate they have certain amount of the clay. Okay, especially clay inside the gradation, the clay, the soil, kind of soil, which this soil, if it like they will have expansion, like in some certain maybe absorbing the water. So yeah, so they are the physical reaction for the ACR.
好，那我再简单讲一下它里面它一定要有几个东西。AAR 如果说只有活性骨材还不成立，它一定要有3个东西，它才会产生 AAR。就是我现在讲的都是用 AAR 来简称，其实是 ASR 啦。如果再更细致，因为你们外面大部分都是讲 AAR， 其实都是在讲 ASR。如果要更区分的话 ，ACR 行为是不一样的。那我不讲 ACR， 我就讲 ASR 好，它一定要有3个形成。第一个，它一定要这个骨材本身是有问题的，就是活性细质骨材就是我说的细阳间接很弱。第二个，混凝土是碱性还是酸性？
碱性，
强碱嘛，对不对？所以它一定有氢氧根离子这氢氧根离子就会去打断这个间接打断这个活性的细氧间接，打断它的时候，它就呈现一个不稳定状态，里面还有什么东西？水泥的碱金属离子。所以为什么刚才 Alan 他有讲说，这个含碱当量要小于多少才可以抑制？那问 Alan 好了，含碱当量要多少？碱含量要多少？小于多少才可以预防？他刚才有讲他在图里面有讲。
So Alan, let's ask you. So you mentioned about like the pH have to be in certain degree, so you can prevent from the AAR to happen. So what's that situation?
Sorry. Can you repeat it?
So in your PowerPoint, you mentioned that the AAR can be restrained, can be held back with a certain pH value. So what's the number for that?
Oh, okay. Wait. Let me check it first. Oh, okay. AR. Certain pH. Wait. Take rise in pH. Certain pH. AR.
Page 48.
48. Okay.
你们看一下它的48页这边有讲。有没有你看水泥的检验一定有一个含碱单量，含碱当量要小于多少
？Acidic rocks composed of silica and silica minerals do not remain stable on long exposure.
好，没关系这边要告诉同学的就是说，它一定要有个活性细质骨材，要有氢氧根离子。那水泥的碱金属离子早期的水泥其实含碱当量是非常高的氧化钠跟氧化钾的那个总和的话0.5658，我就不讲那个计算式了都超过0.6% 以上。后来大家都发现这个问题之后，现在都有限制水泥的含碱当量，不然以前水泥的含碱当量是很高的所以要先了解一下碱骨材的一个反应的一个机理之后，你要怎么去限制它，你要怎么去预防它，你就要从这边去着手第一个它要活性骨材，第二个它必须要 有足够的氢氧根离子和含那个碱金属离子好，这样子它这氢氧根离子去打断它的键解之后，我的碱金属离子去跟它结合，打断之后它不是一个不稳定状态吗？钠跟钾，碱金属离子就是钠跟钾嘛，去跟它结合，结合之后会形成一个碱系胶体。我很快讲完。那碱系胶体吸水之后，这个胶体吸水是会膨胀的，请问它会在哪边吸水膨胀？是不是骨材表面？从骨材表面开始先反应。所以骨材表面就好像钢筋，你把石头想成钢筋，钢筋外表开始产生生锈之后，它就开始不断的反应，它是不是就体积越来越大？碱骨材也是哦，碱骨材是从石头产生的碱系胶体吸水之后，它就开始膨胀，一直去不断的反应之后呢，就会把混凝土给胀裂了。所以呢，你会发现它的裂化的一个部分，如果是就单纯的不是钢筋为数的一个混凝土的部分，它其实很像一个地图状的裂缝，因为它从石头的中心开始去膨胀，好，就会产生一个地图状的裂缝。好，那这边的话，这个是一个很典型的一个碱骨材的反应，但是呢，通常我们再去做桥梁检测等等的部分我们并不会直接说它就是碱骨材反应，还是要拿回来一些化验它化验才能确定。好，那这个你会发现有一些它会伴随着碱系胶体的出来，它跟我们看到的白华是不一样。白华是一个碳酸钙，它是非水溶性，会固解的。这个胶体是吸水之后它会被稀释掉的，所以常常会看到下过雨之后这边根本看不到一个碱系胶体。OK 吗？要跟他们讲一下吗？
好，老师你回报对 OK so actually for AAR there are three requirements. So these three requirements have to be reached so the AAR can happen. The first one of course will be the alkaline aggregate. The aggregate which already have a lot of alkaline. Okay. Yeah. The second one will be the alkaline environment. So Professor here mentioned that in the old way, like before, actually the cement is really the pH value for the cement is really high. So in that case, this kind of AAR happens a lot. So people try to reduce the alkaline environment in the cement. So to decrease, like you mentioned earlier, the equivalent of alkaline should be lower than 0.6. So that's when they decrease. So that's two. The third one will be that there should be water coming in. So if these three happen, so as we mentioned, the AAR was based. This reaction was happen on the aggregate. So the expansion will happen on the surface of the aggregate. So you can consider that's kind of expansion from the interior of the concrete. So this kind of distress or this kind of crack will be looking like a map. You can see that, like you mentioned, so that there will be so many curves on the surface because the expansion was from the inside of the aggregate. 好，老师继续。
好，那这里很简单，这是一个反应的机理，我就不再讲了通常这个碱系胶体会有几种形式，一个是钠钾，有一个是钙系胶体，一个是钠系胶体。那为什么我们都只有讲钠系以钠系为主钠离子跟钾离子？因为钠系胶体的碱系胶体碱系胶体吸水膨胀率比较大，钙系胶体其实它的膨胀率很小所以影响没那么大。好，我只是简单讲一下那这个就是我说的，如果它是一个很整齐、键解很好的非活性骨材，这是不容易产生碱骨材反应，像这样子就很容易好，那我讲一下它的外观它的外观在纯混凝土结构的部分，它会形成刚才说的那个地图状的裂缝，然后会有个渗出物。但是如果是钢筋有 RC 有钢筋的部分，它就不是地图状的裂缝，因为它有微束它会沿着主应力方向去开裂，然后有锈斑。为什么？因为只要开裂之后水就容易进去了嘛，水容易进去的话就很容易产生腐蚀那内部的部分它会有一些裂缝还有胶体，然后呢最重要就是骨材反应会有暗色的反应圈。我想这个我就不用讲，也不用特别跟他们要讲也可以啦我只是要讲一下碱骨材反应的一个相关机理那给大家看一下因为以前的一些相关的成果就是你看它这个骨材旁边有没有它有一些暗色的反应圈，那这白白的就是一个碱系胶体碱系胶体就是吸水膨胀之后就会把这个 这个这边的一个释放压力就会把骨材那个混凝土给撑裂了好，那试验方法刚才那个 Alan 有讲到一些，那我想这也不是我们的重点，你们自己回去看一下说减骨材反应有哪些
这个
Why I cannot hear anything?
喂，老师，好像
I think Professor lost signal.
对老师，
Yeah, we should wait for Professor to. Oh, Professor lost her signal, I think. Professor, your microphone.
老师你的麦没有开，你的设定没有开。
我刚才讲到哪里又跳掉了？
完全没有讲。
我讲了那么久，完全没有讲。
就是看完那个图片，看完那个黑斑跟白色的胶状那个胶体后就停了。
好了，没关系啦，我就不讲太多了。然后我再讲一下还有膨胀的原因还有什么呢？膨胀的原因，刚才不是有讲到硫酸盐侵蚀，讲到减骨材反应 AR， 还有呢就是 Free CaO 跟 Free MgO， 这个也是会游离的氧化钙、氧化镁，其实它跟水做反应之后，其实体积会膨胀的。所以在水泥间性的部分，它就是要去检查它的间性反应，就是在检查这个。那你们讲到钢渣也是因为它有添加了一些石灰岩进去，所以里面也有一些 Free CaO。那 Free CaO 太多，其实对我们混凝土其实是不好的，因为它体积会膨胀。明玉一直在笑，怎么了？怀？
没有，魏老师，没有，刚才 Hugh 问了一些问题，我在 Hugh 解释。
OK
好，
好。然后呢，我看他要讲什么还有膨胀的问题，就是刚才说的钢筋的。
老师断讯了吗？但没偷笑。
又宕机了，是不是？刚才你们有宕机吗？还是
大家都断，
大家都断，不是我啦哈。
对，大家都断。
好，那另外一个膨胀的问题就是钢筋腐蚀。那钢筋腐蚀，我想之后有空，因为钢筋腐蚀也是大家很想要知道的一个部分，有空我再跟大家说明一下。我想已经7点多了，大家而且都没有下课，大家很辛苦了哈，真的很辛苦。那 Alan today's report is great, thank you.
Thank you so much. And sorry for the time.
OK， 非常好。那我们就下礼拜2就 Hugh 先报告，戴米 OK 啦哈。你会不会觉得委屈？还是你要先？
委屈啊，戴米
戴米没事。
还是不然这样子好了，下礼拜2跟 Hugh 讨论一下。
Maybe do you want to do it first, or you want to do it after me? Up to you.
好，那个还是说跟 Hugh 讨论一下，你先戴明先礼拜2报告，然后 Hugh 礼拜3，因为什么？因为 Hugh 你戴明礼拜2，我觉得以你之前的报告都很快速，他超快速的。不像 Alan 这样子，那我觉得 Hugh 应该也是很会讲那 Hugh 礼拜3其实对他说，因为我们后面还有很多时间，我们就让他讲完。大家 OK 啦，辛苦了，没关系。那个戴米还是就是你礼拜2，然后那个 Hugh 就 Wednesday，
都可以。
OK， 那你就礼拜 哦，戴米礼拜二，然后 Hugh 礼拜三。那你跟 Hugh 解释一下，就是说礼拜三其实时间比较多啦哈。戴米礼拜二刚好2个小时 ，OK 啦哈。
So Hugh, so professor say 戴米 on Tuesday and you on Wednesday. So Wednesday you have a lot of time for you to do your presentation. It's much.
Hours.
Yeah, it's okay. It's okay.
因为我觉得 Hugh 应该也会讲很久。那戴米按照黄历的报告，他都因为他会紧张，他速度都很快，咕噜咕噜就结束了。那就礼拜二2节课就给他啦。然后戴米那个 Hugh 礼拜三我们就大家也轻松一点，就真的很累的时候休息一下哈，或者上个厕所都没关系啦。那我们就是这学期真的是就疫情的关系，我们大家就是学到就好了，不要去特别去刁难你们、考你们什么的哈。我们就有可能书面就没有办法考了啦，哈。那其他的话就是会分配到其他的分数里面去，那大家也不用紧张分数了，嘿 ，OK， OK.
Okay, guys, thank you so much for today's presentations and sorry for the time.
我觉得他报告的很好啊。其实你跟他讲，他今天这样的时间是很 OK 的。我们以前都是要报告3个小时，就是要像他这样子，所以是 it's OK 的，嘿。所以 Alan 报告的很好 ，it's OK， 嘿。好，那我们今天就先这样子，不然我怕大家真的从4点到现在已经快要7点半了，应该很累了。谢谢大家 ，Thank you 啊，一凡还好吗 ？Are you OK， 一凡
，how are you? Oh, sorry, he hard to speak.
OK，
Yeah.
OK， 因为好 ，take care 哈，好，那就先这样子喽哈，好，拜
拜 ，Thank you so much， 拜拜 ，I will stop the recording。
那个郑凯，谢谢你呢，
不会，
有你真好，OK， 好，拜拜，
拜拜。